Suaranya kedengeran, Ray?
Kedengeran? Ya, bikin
Bisa didengar.
Oke.
Good morning, everyone that is here now in the NR01 room. Would you be so kind to confirm that you can hear my voice clearly?
Yeah. It's all right.
Yes.
Okay.
Pak Renaldi.
Okay, good. Thank you so much. While we are waiting for 10:35, that we will try to confirm the speakers here. We have Professor Benjamin Sapii. It's already here. I think the next one will be Bari Majid, yeah, Hartono. Maybe he's still finding ways to come into this room. And there's Michael Timothy. Okay, I still not see Michael here. Pak Sena Reksalagora is here. Morning, Pak.
Morning.
And then the last one will be Devito Pradipta. So we will wait for the other speakers to join us, and then we will start at 10:35 sharp. Okay, thank you. Pak Mino will present the talk live, ya Pak ya. If you want to try to share the screen,
Okay, I will.
you may do it to test.
You see?
Okay, yeah, clear, Pak. Clear. Good, very good. Okay, Bismillahirrahmanirrahim. I will start this session with a rolling start. So hopefully at 10:35, Pak Mino will start giving his talk. So, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning, everybody. Thank you for joining us in this first parallel session in natural resources in room NR01. There will be 5 speakers. First is Professor Benjamin Sapii as invited speaker. Second, we will have Pari Majid Hartono. The next one will be Michael Timothy Tasliman. And then after that, we will have Pak Sena Reksalegora. And then the last one will be Devito Pradipta. So this session will talk about natural resources. So the first speaker is our invited speaker, Professor Benjamin Sapii, is world-renowned structural geologist. He has worked in many exploration projects, especially in hydrocarbons. But this morning, he will talk about something different. So it would be very interesting because he will be giving a talk about how earth sciences will help in the future for sustainable development through CCS or CCUS. So in this session, we will explore that knowledge here. So for Pak Mino, I welcome you to present your talk.
Thank you very much, Mr. Seven, Pak Ray. So I will start sharing screen. So everybody can see my screen now.
Yes, Pak, very clear.
Okay. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. As mentioned by Ray, so today I would like to actually very light talks concerning our contributions to the global warmings in terms of CCS and CCUS technology, which is now starting applying in Indonesia. So this program actually related to the Paris agreements that Indonesia also will try to reduce CO2 emissions in order to reach increasing temperature below 2 degrees. So my outline of the talk will consist of 5 different points here, but mostly very, very light and mostly very, very show and tell type of informations. So in order to involving in the global warming, Indonesia have also reduced their CO2 emissions. So this slide showing that our contribution in the term of CO2 emissions consists of industrial type contributions, and also oil and gas contribution, or we call it fossil fuels. So we can see that within per years we have a contribution for what so-called industrial is 126, and the data from EIA from the oil and gas field is about 49 metric ton. Most of them, the bigger one, is came from the coal. So ADB report 2019 showing also the biggest one is came from the power plants, which is basically mostly engines by coal. So I will start with the what is actually CCS. CCS is a carbon capture and storage. So basically, it's the technology is the way to reducing carbon emissions. And how we going to do it? So we have to capture it first, and then later on we will store in the geological formations. That's why we will as earth science we will involve in this one quite detail. But this is a transdisciplinary issue, so we will contribute in the term of certain points within the workflow. But MIT study showing that this diagram show that the CCS is actually very effective and potentially remove about 90 or 99% CO2 emissions from the industrial factory. As the graph show, without CCS programs and with the CCS programs for the natural gas source of energy and coal, so they significantly reduce. So this is quite important. So CCS become like a main technology for one of the reducing for industrial CO2 contributions. So CCS, sometimes we call it geosequestrations. The one that I will focus in CCS in the geosequestrations. What geosequestration is injecting CO2 to underground geological formations, which is generally in the supercritical forms. I will discuss later on with the supercritical forms. And the target is depleted oil and gas field, or the what we call saline formations, so basically undeveloped latent prospect in oil and gas, or unminable coal seams, and also has been considered as a saline field basalt formation, which is under oceanic crust. And then the issue requirements is mostly to think that focusing first thing is you have to have impermeable cap rocks, which is will be trapping your CO2, and the possibility as a geochemical trapping mechanisms. When the CO2 will react with the rocks, and then both of them will be prevent that escaping CO2 to the surface. So in general, this technology will improve source, which is its best way is close to the capture process. It's also close to the storage area. So from the source will be captured, processing, separation, and then transported, and then storage. So the storage we're talking about is what we call a geological storage or geological formation. So basically, mostly the geological formation is related to the depleted oil and gas, or now we entering what we call carbon captures utilization and storage, which is using CO2 as a fluid, working fluids within the oil field to enhance oil and gas recovery. So it's number 2. We do it enhance oil and gas recovery, so become CCUS here because we have again some other economic value from the field, or to the saline formations, or also using EOR for enhanced coal bed methanes in the term of other requirements. So this is showing you how we're going to do it within the important of the CCUS is mostly related to the EOR and EGR. In here, you can see that CO2 become working fluid is also recycled back to the reservoir. We can do over and over, and then we gain more oil that we can hydrocarbon we can recover from the reservoir. So this is a very interesting concepts and very important in the term of depleted oil fields such as Indonesians, most of the Indonesian oil field. I mentioned about supercriticals. So basically CO2 in supercritical will be no separation between liquid and gas vapor forms. So we are in the supercriticals, mostly more dense than CO2 in that case, also become more compressibles. But their requirements is about 31 degrees C and about 8.38 megapascal. So this is if this is the reach, so CO2 become more effective as a fluid for storage. In the term trapping mechanisms, it will be related to the storage security. So the first one you injected and mostly dealing with the structures in stratigraphic traps, but over time we would like to have something related to the mineral. So basically, you can see this mineral, for instance, in the carbonates, the reaction with the form carbonates within the grain, or the one which is solubility, or the one in the free phase. So the one in the free phase, which is the structures, will be have to bound by low permeability cap rocks, which is very important to make sure that there is no leaking. So in the term of geometry is somewhere like this. So basically around 1 or less than 2 kilometers, we have to find the location of the traps, because in order to get supercritical conditions, and then inject it, and then hopefully we will have cap over the time, which is related to the also mineral trapping, so become more secure. So what is the issue about this technology related to the geoscience? Of course, it's really related to the reservoir characterizations, and also for the structural trapping issue. So the main issue that we need to do is to make sure that our topsoil is impermeable. So in order to do that, why we need that? Because the CO2 injection will form columns of CO2 have to be held by this cap rock. So the cap rocks have to be able to hold CO2 column. As we know, if we use depleted reservoir, we already have a very good traps oil and gas which has been produced. So naturally, this one is already become a traps. So basically, we do have a topsoil which is already impermeable. But to make sure, usually we use what we call MICP experiments to get the information concerning the ability for the trap to hold CO2. The other issue for the geomechanics is related to the faults. Some of the traps will be related to the faults as bonded. So there is a issue of the fault ceilings and also fault stability. So basically, the changing of the pressure of the reservoirs, which is basically not natural because we injected certain column in certain times. So we have to make sure that first that our topsoil is not brittle, otherwise it will be hydraulically fractures. Second, the fault is not moved. So this is certain that we have to have this pressure difference, maximum pressure difference, in order to keep the faults and topsoil stables. So we need information stressed in the term of subsurface information. So a regular workflow usually used in the CCS CCUS project, given by Gibson and Poole. So we have first site selections. Of course, it will be related to all the geoscience informations. And then we go to characterizations. This is the reservoir, the stratigraphic, the structures, and then also during injection. Injection mostly engineering type of words, but we contribute in the term of hydrodynamics and also geomechanics for the stability. And then we have to have monitorings at the time after the injections. Will be another technology which is related mostly for the geophysical world. So this is the one that we have to follow. If we want to do just saline aquifer, meaning we don't have any information concerning the productions or hydrocarbon, there is no hydrocarbons on the waters. So we need to have this information concerning the reservoir, as we know, and also concerning the hydrogeology. Actually, the most important part is this water is not the drinking waters that used for the storage for the reservoir. So there is a very concern concerning the regulatory for the waters in order to inject, because they will be as a reserve for the water. Now, I jump a little bit to the sea, a little bit about Indonesian. So as we see now, this is the map of Indonesians. Indonesian is an active area tectonically, which is interaction between three major plates: Australian, Eurasian, and Pacific. And then in the term of geology, is a long history of subductions. But when we put gravity maps in the say this is anomaly gravity map regional Indonesia, you can see very clearly concerning the basement lithology, anomaly gravity between positive and negative, and also you can see very clearly sedimentary basins and also the tectonic boundary. So it's quite clear for Indonesian regionally, although it's quite complex, but we can maps it quite clearly. This is the tectonic map, which is we can see based on the geological data, seismic data, as well as the earthquakes and volcanoes. So we can divide it Indonesian in general within the western and eastern Indonesia. So we can have this just glimpse a little bit about plate boundaries in the today. So we have various different type of the continental and oceanic crust, so lithospheric difference. And so also we have active slag slip faulting and active transform margin. So not meant to mention that we have a very active subduction zone, which is concerning as the source of megathrust. All these parameters have to be considered if we want to have a very long-term storage. So we have to make sure that effect of the earthquakes and volcano will be safe to have that type of storage. Just a little bit, maybe you all know about the tectonic of Indonesia historically, long subduction as developed by Robert Hall 2012 here. You can see that mostly Western Indonesia is older than the Eastern Indonesian margin. They combine between Western and Eastern only maybe for the last 10 million years. And then overlay that, we have tertiary basin. So we have tertiary basin, which mostly divided between Western and Eastern. So tertiary basin is developed mostly in the Westerns because, as mentioned, that the Western Indonesia is older. Mostly Eastern Indonesia is developed Pacific margins with a little bit tertiary basin. That light color here showing all the produced basins, which is basically now already depleted. For instance, I highlight this Arun gas field, which is pretty much stopped produced. but this will be have more than 4 TCF gas, so this will be very good storage capacity. And then also we have highlight here 3 area we have quite already have CO2 contents within the reservoirs naturally, so it will become a good source to help EOR in the surrounding area. So that's another additional information. This is just a regional section. We can see that's our basin. Produce basin mostly consists of back arc basins, and it's also interior plates. So basically, in theory, the interior plate is more safe than the back arc basin, because back arc basin related to the volcano activity, and it's also a special earthquakes activity. This is another section from the Sundaland up to the eastern Indonesia. You can see that's another type of extended crust basin, which is related to the Makassar Strait and the East Kalimantan margin. So eastern Indonesia mostly related to the collisional type of structures. So let us see about the regional of the Western Indonesia as related to the stratigraphy. We can see, so basically almost similar, all the basins in the Western Indonesia. We starting with the basin filling. Sometimes we call it syn reef. And then we have a transgressive sequence, which is basically post reef. And then we have another clastic deposit, which is, we call it syn inversion or syn orogenic, but this is related. So we have pretty much in the simple way, our regional seal will be related to the positive sequence. So our reservoir could be related with the syn reef or related to the post reef, as well as possible in the inversion. So all these basin actually pretty much have the same play concepts. So we can find oil in the syn reef sequence, we can find oil in the post reef sequence, or even in the inversion related. And then we also have very good oil fields related to the carbonate buildups, which is very important. For instance, like iron gas field, which is now also becoming target for the CCS regional project. This is another picture of the Sumatra. If you can see all the Sumatra basin, North Sumatra, Central, and South Sumatra, they're all in the back arc type of basin. So this is, we have plenty of structures that we can use for the CCS or CCUS program. This is just picture how one of the Central Sumatra. You can see the most of the reservoirs in the reef, and it's also the structure type of the traps. So we can see that our traps will be a structure traps, which is bonded by fault mostly. Although they are large storage capacity, mostly excellent reservoirs, but we have very complex structures. And in some place we have very high heat flows. That's the challenge. And then we will see South Sumatra Basin, for instance, also the same thing. We have various different lithology. We have very good top seal thick of the Guma formation here. So everything below here will be quite protected as impermeable seal. So we have lots of numerous oil and gas fields. And then also very good data set. Like I mentioned, near CO2, either plant, coal, power plant, coal as a source. We also got from the reservoir itself, like I mentioned earlier, more than 50% CO2, some of the CO2 recovered from the reservoir. Infrastructures and also thick and multiple layer reservoirs. They have also very good carbonate reservoir. So South Sumatra Basin is quite good. And then we have Northwest Java Basin. This is lots of power plants in Java that are covered by these basins also. So we have what we call pilot projects in the Gundi area. So we have that special project related to the limestone or build up limestone in the East Java area. So we are ongoing studying these pilot projects with is a joint project with Japan and ADB in Pertamina. So, but basically, we try to use EOR as our main, so CCUS mostly to store CO2 from the surrounding area, and also increase productions of the Gundi area. This is just the pictures of the possibility we can have the Sukowati limestone mostly in the build up. So basically reservoir characterizations and also character for the reservoir carbonate is more complex. But now we also have possibility. Also now we have mineral trappings during the process. So this is the one that we need to also studying concerning the geochemistry related to the probability mineral trappings more dominance than the other type of trappings. Okay, in summary, by Iskandar et al. 2013 has been studied that various different places in Western Indonesia and Eastern Indonesian basins have capacity of the storage CO2, mostly for CCS and CCUS, but CCUS mostly expected because the most of the field is depleted oil field and depleted gas reservoir. So we do have various different. So we have been studying what now decision have been made for the Bintuni or Tangguh oil field as the AGR. Now we study number 5 here for the area, and we have other plenty reservoir that we need to be able to store CO2 in terms of CCS and CCUS technology. And then study nicely done by Diana et al. 2016 is also showing that for the possible CCUS project in South Sumatra as well as Java have quite a significant opportunity where the both have to be very, very huge capacity to store CO2. Some of them is very huge, like a gigatons type of store. So we have capacity, we have very good reservoir, and we have a source of CO2, as well as we have very good infrastructure. However, today we still lack of the regulations and how to do this process. So that's another challenge we need to do in the term Indonesia. But I hope you can see this is an opportunity for the young geologists, young geophysicists, or others environmentalists to have this in the futures as a part their contribution to the global warming. This is a transdisciplinary issue, not only about reservoir, but about environmentals and about engineering to make sure that our reservoir is safe, sound for the rest of the time. And then the other issue is we have to be able to develop monitoring technology to make sure that no CO2 leak to the area. So I think this is very good future for us to be able to do, particularly in the term of CCUS, where all the oil field and gas field in Indonesia, particularly West Indonesia, will be depleted situations. So I think this the one that I will to discuss today. So we have basically 89 tertiary sedimentary basin, 16 of them is a production, and then we know they are very good capacity for doing CCS or CCUS. And then also challenging because there is an issue concerning the active tectonics at the moment. So it will be need to work more in the term of affected present day earthquake to the our storage. But no doubt we have very good reservoirs, although some of them quite structurally complex. But there is basins also have very good. So in the term of source is very good, but in term of economic it will be challenging. For instance, in Natuna have very 70% CO2. So it will be produce CO2 rather than gas. So there is another way. There is an idea that we produce CO2 and then we use it for the injected to other field. This will be opportunity in the future too. And then the other one is opportunity for Indonesia, for other country to store their CO2 in Indonesia. There's another possibility which is still open. So the main challenge is actually, like I said, structurally complex, and some of them need transportations, which is quite expensive in the term of operation CO2. So if you want to classify, ranking the best area for the EOR CCS at the moment is the Central and South Sumatra Basin. And then for the EGR, actually Kutai and East Java and Bintuni. Bintuni is already ongoing, so we have other also now in the East Java area. So maybe the next is we can concentrate in the Kutai Basin. I think that's things I would like to share today. So this will be using for students to concentrate, particularly in the term of sustainable developments and related to the green energy concept. So thank you very much for listening. So I will close my presentation.
Thank you, Professor Mino, for insightful presentation on CCS. Now we have less than 5 minutes for question and answer, so I will take one or two questions. There is Pak Sena Reksalagora that has raised his hand, so please, Pak, silakan.
Okay, thank you very much, Mr. Chairman. Nice presentation, Pak Mino. Thank you very much. Really open a lot of eyes on this topic, I think, because this topic has been started to emerge in our discussion. Okay, so you already mentioned that basically the study has been around, storage capacity has been studied, and then the challenge also has been scrutinized here, especially in the subsurface challenge. So I think that's I will call it, that's pretty much already in place. Now I'm just curious, this is really something that getting into the end. Is there any kind of economic sensitivity of this type of project? Just kind of is it going to be a positive or negative type of thing? Because again, when you're talking about CO2, you're talking about the kind of expensive type of equipment, because that's a special case. CO2 is not something that we can treat as similar with kind of gas type of other type of gas. So I think that's should be a simple question for you. Thank you.
Thank you very Pasena. Yes, that's why based on our current study between just storage CO2 versus utilization of the CO2. So at the moment, most of the companies will do green energy things toward the CCUS because they gain something from the oil. So based on our study, economically, for instance, I cannot say the number, but economically for the Bintuni Basin, what we did with BP, now or designed also by government, that increase not significantly, but adding more economic. So it's basically they don't have any costs. They operate CS, but they gain a little bit from there. So that's the CCUS term. But in our opinion, because Bintuni also have very good reservoir, they have very, very good reservoir and very simple system. It's not different with the now in Gundi, for instance, we have carbonate reservoir, more complex reservoir. So it could be not economically is challenging. Yeah. But for just at the moment for just doing CCS, I think it's not economically, it's not feasible in the moment. So, but for oil and gas, but for other companies, maybe for instance, because their requirement to do that, maybe they will do CCS for the saline aquifer. So it's the shallow looking for the something more just small amount of CO2 per year, but you don't have to deal with the too many different things. So a saline aquifer is just leads or prospect is not unreal mobile water. So the issue of the saline is the regulation for the groundwater issue. That's main issue. However, at the moment, government of Indonesia doesn't have any regulation yet concerning CO2. So that's the more challenged issues actually. So this is we running around study this, but there is no regulation yet actually how we going to do that. For instance, this company want to store the other company's reservoir, can they do that and then gain some credit from the doing that? And then the other thing is, I have reservoir, can I rent it to you to store in our place and then gain a credit? So that's an all that kind of issue, not let alone somebody from outside the country want to store their CO2 in our country. So Singapore is already mentioning that they will do their CO2 captures and they will store it in our own. That's weird. I think for them the best is Arun because the distance and also the huge storage capacity. But we don't have any rules yet. I mean, any government rules about it. But yeah, this question is about economic at the moment. But pretty soon, unless they are, but pretty soon there will be some kind like treatment. But as in, maybe you've seen that from MIT study, this is very, very effective using CO2 as a using CCS as a main operation technology for the CO2 for industry. While they still keep burning, but they can go also to store it. Yeah. Because they don't want to stop the coal power plant. Actually, that's maybe the issue.
Yeah, that's a very interesting issue. Thank you, Pa Sena, for the question, and Pa Mino for the discussion. So yeah, basically CCS is very dynamic. So the issue is right now, basically, the world is going that direction. So is to prepare ourselves is the issue. Yeah, Pak Mino ya. Jadi so when the platform is ready, so we should be ready too. So that's why we should try to restart lah seperti itu ya untuk CCS ini seperti itu.
Yes, students have to be knowledge about this because this is maybe the opportunity for work
in the future. Yes, yes, very nice. Again, I would like to thank Professor Benjamin Sapi for the first talk today in this parallel session for the insightful presentation. Please give a big round of applause for Pak Mino. Terima kasih, Pak.
Thank you very much, Fari.
Okay, so we will move on to the second speakers. We have here in the schedule Mr. Bari Majid Hartono. Are you here?
Yes, Yes, I'm here. Can you hear me?
Okay, good. Yeah, so we a little bit behind the schedule, so we will have 20-minute sessions for the speakers. If you can keep your presentation in 15 minutes, and then we will have slots for question and answer for 5 minutes. Okay, without waiting any longer, please welcome Bari Majid Hartono. Thank you.
Thank you very much for the opportunity. So I will start to share my screen first. Can you see my screen?
Yes.
Okay, I will start the slideshow. Okay, thank you very much. Good morning, everyone. Hope you are doing well. Please welcome to the International Seminar on Earth Sciences and Technology 2021. First of all, I would like to say thank you for joining my presentation entitled The Significant Meaning of Biodegradation to the Petroleum System of the Seram Basin, Eastern Indonesia, Evaluation on the Basis of Physiochemical Composition Variation of Seram Oils. It is actually a novel application using biodegradation to study petroleum system history in Indonesia. So my name is Bari Majid Hartono, and I will become the presenter for the next 15 minutes. A short introduction about me. Currently, I'm a master's student at Geological Engineering ITB, and I've also affiliated with several professional organizations such as AAPG, IPA, SPE, IAGN, and FOSI. My main interest lies on petroleum geochemistry, basin analysis, organic geochemistry, and rare earth geochemistry. And since 2018, I've already written 17 publications. If you are interested with my research, you could follow me on LinkedIn or ResearchGate. So before I begin my presentation, I would also like to acknowledge my co-authors. There are Professor Edi Subroto and Dr. Asep Sumajana, both of my supervisors for my thesis, and then Mr. Bagus Prianto from Geological Engineering ITB, and then Mr. Roy Andrianto and Mr. Galung Malvinas from Sidik Seram Energy Limited, and Dr. Joko Ayudiono from Pusat Survey Geology. So the presentation outline today, we will discuss the background of my study, and then a short definition and the effect of biodegradation to the hydrocarbon, especially crude oils. And then a short description about petroleum system of Seram Basin, the new one, the updated one. And then our methodologies, result and discussions, and we close it with the implication of studying biodegradation to the petroleum system. Now, before I begin my presentation, I would like to start my presentation with a few words, which is hydrocarbon preservation is important. So after the hydrocarbon are expelled from the source rock, the hydrocarbon must preserve during migration or after being accumulated in the reservoir. And several alterations could happen, such as migration fractionation, migration contamination, water washing, and biodegradation. But in this study, we will focus on biodegradation. So what is biodegradation? Biodegradation is a hydrocarbon destruction process by microbial activities that stand for the bio that modify the physiochemical composition. So because biodegradation is hydrocarbon destruction, then it brings negative effects such as fallacy on geochemical correlation because the crude oils have been modified, the geochemical composition, and also significantly reduce commerciality of oil production because biodegradation lower the API values of oil and increase the viscosity. So it will significantly affect the production of oil. However, despite of the negative effect, could biodegradation provide information about petroleum system history? Yes, the study will demonstrate how the different degree of biodegradation in each field could tell the petroleum system history with a case from Seram Basin, Eastern Indonesia. Seram Basin was chosen since has been known that the crude oils in this basin have been extensively affected by biodegradation. So a short introduction about biodegradation. Biodegradation destroy the light fraction of hydrocarbons starting from hexane to the heavier fractions. And in terms of the hydrocarbon fraction, we can know there are four type of hydrocarbon: the normal one, the branch, the isoalkanes, cycloalkanes, and aromatics. And the biodegradation tend to destroy the normal one, and to the most resistant one, the aromatics. And the study will use Wenger et al. 2002 classification here. And because biodegradation destroy the normal alkane first, the saturate fraction, then it would lower the API gravity and increase oil viscosity. And due to the data availability, only these parameters that we use in the study. Now, a short description about the petroleum system of Seram Basin is Most of the oil are retrieved from Jurassic Manusela carbonate, the pre-tertiary reservoir, and the Quaternary fuva-clastic reservoir. That suggests the main source rock acting in the Seram Basin is actually the pre-tertiary carbonate intervals leaving Saman-Saman Formation and Manusela Formation. However, Hartono et al., our previous study, and it will be discussed in my next talk this afternoon, updated and proposed a new petroleum system model for Seram Basin that encompass two possible source rocks. So Saman-Saman Formation and Manusela Formation is actually both acting as source rock, and then the occurrence of intraformational migration and the tertiary migration. And we interpret that the Neogene collisional event, the Banda collision, is interpreted to be responsible for source rock maturation, expulsion, and hydrocarbon migration, both primary or tertiary. So our methodologies, we collect oil samples from Manusela carbonate and the fuva-clastic reservoir, and we perform oil geochemistry study, and we see the relation between several biomarker parameters with depth and also the biodegradation level and its effect on hydrocarbon in each oil. One should be noted that to study biodegradation, knowledge of primary control on oil geochemical composition must be established, and we have already studied that. And the biodegradation must to be validated with the geological condition, especially the reservoir condition that encompass reservoir temperature and salinities. Then the biodegradation, we will see the geographical distribution, and we match it with the tectonic history and also the petroleum system history. Now, we want to detect the early sign of biodegradation. As we can see here, Seram oils display wide variation in terms of saturate aromatic fraction compared to the polar fraction, the nitrogen, sulfur, oxygen, and asphaltene fraction. And this wide variation could be resulted from four factors. So the origin of oils, the maturity, that we call it as primary controls, hydrocarbon migration, and post-expulsion alteration, that we call it as secondary controls. Fortunately, the primary controls could be eliminated since our previous study have confirmed that Seram oils display similar origin and maturity. And we also see that there is general trend of increasing percent sulfur with decreasing API values, indicating that biodegradation is possible because biodegradation tend to eat the saturate fraction, leaving the polar compound. So it will give this similar trend. And then based on the geographical distribution, as we can see here in the Lofin field, the newly drilled oil field, have a relatively high saturate fraction. We can see the blue portion here is relatively big and greatly reduced in the Nia field and Bula field. So it is decreasing the saturate fraction. And also the nitrogen sulfur oxygen fraction also tend to increase greatly to the eastern and northern oil field. We can see the lower portion, the green one here, to the most in the east, we have a relatively huge portion of NSO fraction. And we also see the relation between several parameters with depth, such as API, sulfur percent, and saturate per NSO depth, because biodegradation by concept is progressively extensive in the shallower reservoir, since in the deeper we have a relatively high geothermal gradient and reservoir temperature will be high, so it will inhibit bacterials. Consequently, we can see here the API values is relatively lower in the shallower reservoir, both from the oils retrieved from Manusela reservoir, pre-fuva reservoir, and fuva reservoir. And then the saturate per NSO fraction also relatively lower in the shallow reservoir. And the sulfur is relatively higher in the deeper reservoir. And then that's the possibilities. Now we will discuss each level in the oil field. In the Lofin field, we can see the Lofin oil have a relatively high API, low sulfur, and high saturate fractions, indicating that these oils are unaltered, and it is supported because the hexane to the dodecane still observed, suggesting that Lofin fields are non-biodegraded. And the reservoir conditions validate this condition because the reservoir salinity is only 14 PSU, practical salinity unit, that still open up possibilities for biodegradation to occur since bacteria died at 100 PSU. But the reservoir temperature reached 250 Fahrenheit, inhibiting bacterial activities because bacteria died at 160 Fahrenheit. And then in the Noinia field, we have a low to moderate API values, moderate sulfur, and relatively low saturate fraction, indicate that oil from near field are unaltered. And this is also supported by the hexane and the dodecane still intact, no unresolved complex mixture or UCM are observed, suggesting no biodegradation. So what caused the alteration? We interpret this because of other hydrocarbon alteration, such as water washing. And no biodegradation is also validated with the reservoir temperature reach 175 Fahrenheit. Once again, it is inhibiting bacterial activities in the near field. In the ocell field, we have also the lowest API compared to the oil field. High sulfur and moderate saturate fractions indicate that oils from ocell fields are altered. And we can see the hexane to the dodecane are still intact, but we have a slight UCM are observed, suggesting that the oils from ocell field are interpreted non-biodegraded or at least lightly biodegraded or level 1 biodegradation. Low API, once again, we interpret as because other hydrocarbon alterations such as water washing. The geological validations also validate that these oils should be not biodegraded because the reservoir temperature reached 165 Fahrenheit, slightly higher than the bacterial to live in the 160 Fahrenheit. And now the final field, oil from Bula field, we can see there's different with the other oil fields. It is clearly destroyed. We can see a high UCM here, suggesting the occurrence of biodegradation, and we cannot see the peak. So we cannot see the normal alkanes and isoprenoid, suggesting that oil in the Bula fields are undergo severe biodegradation, at least at level 4 biodegradations, more than level 4 biodegradation. Now we want to answer specifically what level biodegradation in oil Bula field is. We take it from the case from B1 well. As we can see here, the bicyclic alkane is still intact, so it is safe now. And then the terpene, it is still intact too, and the styrene is still intact. And how about the occurrence of 25 norhopanes? Now, to observe the 25 norhopane, we could observe it in the MZ1277. If the 25 norhopane is observed, then the peak must to be shift a little bit in the right. But we can see here the peak is in line with the MZ1277, suggesting that the 25 norhopane have not been formed. Therefore, several oil in Bula fields undergo severe biodegradation in level 4 biodegradation. So now, what is the implication of biodegradation to the petroleum system? We must to take notes. 1, the oils in the low-fin field are not biodegraded. Level 0, ocell field are not biodegraded to slightly biodegraded. Level 0 to level 1. Oils in near fields are not biodegraded. Level 0. And oils in the Bula field are severely biodegraded, level 4 to level 5. And to summarize, we can clearly see that biodegradation tends to be more extensive on the northern oil fields compared to the southern oil field. It is related to the nitrogen deformation that leaked the previous accumulation in Manusela formation, supporting the model proposed by us, our previous study. So the previous accumulated oil in Manusela formation are leaked from the shale because of the thrust formed in the Nigen, maybe in the Miocene. So the leakage of the seal lead to the tertiary migration. So the previous accumulated oil will be accumulated in the shallower reservoir in the Fuva formation that provide a suitable condition for microbial activities. So to conclude, this study successfully demonstrates how oil biodegradation provides essential information regarding the petroleum system. In this case, the different degree across Seram oil field is in line with the newly proposed petroleum system model of Seram Basin, and extensive biodegradation of hydrocarbon in the Bula fields indirectly is the result of the tectonic history, specifically on Nigen deformation due to the Banda collisions during Miocene. Before I close my presentation, I would also like to acknowledge my CITIC Seram Energy Limited and Pusat Survey Geology that have provided the data and allowed this research to be presented at International Seminar on Sciences and Technology 2021. Please join our next talk in the afternoon entitled New Interpretation of Nature and Origin of Carbonate-Derived Oil in Seram Basin Eastern Indonesia, that will discuss more detail about our proposed, a new proposed model for Seram Basin petroleum system. Thank you very much for your attention. Please feel free to give us questions and have discussion. Terima kasih banyak.
Okay. Thank you, Barry, for very comprehensive presentation in a very short period. Yeah, we appreciate it. You are in time. We still have 5 minutes for question and answer. So for the participants, if you'd like to ask directly, please raise your hand, or if you can give me a chat so I can read it to Barry, you are welcome to do so. Okay, so because while we are waiting for the question, I would like to ask you, so like this title here, the significant meaning, the significant meaning. So what is significant? Like, is it significant to the critical time on the petroleum systems, or is that still unclear to me? Like, what is significant?
Okay. Thank you very much for the questions, Pak Reynaldi. Let me answer you based on this image, based on this picture. So yes, the significances of the biodegradation will tell us about the timing, of the expulsion between the Saman-Saman formation and Manusela formation. Actually, it will be discussed. More detailed in my other talks about the petroleum system, but there are further challenges that must to be answered. One of the challenges is we must to see the degree of biodegradation, because if we divide the oils into two family A and family B. Family A is expelled first, and then the family B expelled later. And the first expelled oil, the family A, will accumulate it first in the Manusela formation. Based on our concept, if the family A is leaked to the shallow reservoir and followed by the family B expulsion, then it should that family A must to be more biodegraded to compared to the family B oil, because they are the family A have also undergone the migration and then tertiary migration also. So yes, the biodegradation, the difference of biodegradation degree will tell us
Manusela to the younger Fufa formation, how is the mechanism. But it's very interesting. I would love to see your next talk in the afternoon. But first, I will give time to Professor Edi Subroto to ask questions. Please, Pak.
Mr. Chairman, can you hear my voice?
A little bit muffled, Pak. Mungkin.
Is that what's the problem with mine?
A little bit, yeah, just a little bit, but we can hear you.
Yeah. Okay then, Barry. That's very excellent presentation. I enjoy hearing your presentation. It's just a small question. When you do this one, is that mainly for research purpose, or there is an implication in the exploration of the oil in your area? Thank you.
Okay, thank you for the question, Paidi. Actually, Paidi is my supervisors, my thesis supervisors. Yeah, it is for the sake of scientific knowledge. But if we want to apply this concept to the exploration, for example, to confirming our proposed model, yes, we can use this biodegradation, the different degree of biodegradation concept to exploration, to tell the different timing like that. Paidi, I hope that answered you, Pak.
Okay, thank you, Barry.
Thank you, Professor Edi Subroto and Barry, for the excellent presentation and research, for sure. Yeah, we are looking forward to seeing your other results. Yeah. Okay, so we are now 11:30, so we have ended our second sessions. The next one will be given by Michael Timothy Tasliman. I would like to confirm your attendance here. Okay. It looks like Michael is not present with us here right now, so we will have a little bit time for each of the speakers, assuming Michael is not showing up until the end of the session. So maybe I will move to the next speaker, Pak Sena Reksalagora.
Okay. Okay.
So if you are okay with starting earlier, Pak?
Yes, that's fine with me.
Okay, so we will have a little bit more time for you and for the next speakers to complete this parallel session until 12:30. So we will have a little bit, free time to juggle around. So without further ado, time and place virtually is yours, Pak Sena, please.
Okay, thank you very much. I will share the screen first. Okay, so hopefully you can see the screen, yeah?
Yeah, very clearly. Thank you.
Okay. Okay, thank you, Mr. Chairman. Good morning, everybody. As mentioned, or I don't know, already on the abstract, I think the title of my presentation today is a tectonic-induced overpressure in Madura Sub-Basin, East Java Basin, Indonesia. So beside myself, the followings are the authors contributed to this work: Professor Lambok, the late Dr. Agus Harsolu Maxo, and Agus Ramdan, PhD. Okay. Okay, this is the agenda of my talk. I will start with the introduction, then we'll be talking a little bit on the data processing, and then continue with discussion on the stress regime and the overpressure main generating mechanism before ending with the conclusion. Okay, so this morning we already heard Professor Cumming and Professor Klaus talking about a lot about subduction zone. So here's another topic, I think, that kind of relate to the that topic. You know, previously you're talking about disaster and then and also the opportunity, but now here's another influence to what the overpressure in this study area. So basically the study area is located in the Madura Sub-Basin, which is part of the larger East Java Basin, and the study area is mostly located in the offshore area. So the East Java Basin is a tertiary backup basin and is one of many producing hydrocarbon basin in Indonesia. The study area is well known for having overpressure zones and is also well known for having complex tectonic history and complex sedimentation. So the study area is part of a worldwide area where pore pressure is affected by tectonic processes. I would like to take the opportunity to acknowledge Pusdatin of Kementerian ISDM Republik Indonesia for giving me the access to the abundant data that is used in this study as shown on this piece map. Okay, overpressure is common in the onshore East Java Basin as discussed in many publications. And mud volcano is one indicator for the presence of overpressure zone as shown by this red triangle. The most recent mud volcano is Lucy. It's location of Lucy, which was erupted in 2006 and is still active until now. And the picture of Lucy on the right side here illustrate the dimension of the mud volcano, which is quite large. So it's about looking at the scale is 2 by 4 kilometers here, just the wall itself. The red dots are location of overpressure wells in the onshore area. The top overpressure is penetrated around 600 to 1600 meters within Pleistocene to recent interval. So it's very, quite shallow in a quite young interval. And the disequilibrium compaction due to rapid sedimentation was interpreted as the overpressure generating mechanism in these onshore wells. Okay, in terms of regional geology, the study area is located at the southeastern edge of Sunda Craton, and the study area is located only approximately 600 kilometers from the Java Trench. It's the subduction zone where the Indo-Asian plate subducted beneath the Sunda Craton. And the East Java Basin, as mentioned, is a back arc basin associated with the volcanic arc, trending in west to east direction along the Java Island. On the right side is the world stress map, which shows the study area with north-northeast, south-southwest regional compressional stress direction. And in terms of the stress regime, that's the stress regime right there. That's so the study area is located in the strike slip stress regime. The structural pattern of the East Java Basin is controlled by two directions of main structural patterns: the northeast-southwest Meratus trend and the west-east Sakala trend, which is known as the strike slip RMKS zone or Rembang Madura Kangean Sakala trend. And the stratigraphic of the study area in general reflects the balance between carbonate and plastic deposited in the marine environment, as illustrated in this schematic cross-section. Okay, now we are going to move to data processing. The overpressure zone in the study area can easily be recognized from logs and from both direct and pressure measurement. This is the log from sonic log. You can easily identify the overpressure zone. And then from the direct and indirect pressure measurement, such as RFT, MDT, DST, FMT, or even mud weight. And almost all wells in the study area has overpressure. And there is no common top overpressure in the study area. And the top overpressure in the study area is ranging between 300 to 1500 meters below ground level or below mud level. And in general, top overpressure can be found within the Pleistocene to recent interval. So the overpressure information in the offshore area seems to be consistent with the onshore information. And here's the seismic data, which clearly shows folding and thrusting as a result of tectonic compressional, as demonstrated in this two north-south seismic example. The present-day structural configuration as a result of the interpretation of the seismic from older to younger, in general shows a relatively consistent picture with highs in the northern side and the southern side, which separated by lows in the middle. So high in the north, high in the south, and lows in the middle. And here's the isopath map which shows quite interesting facts here. The depot center was located in the northern side of the study area until late Miocene, and later shifted to the middle of the study area in the younger period. And this is an arbitrary west to east structural cross-section across the study area. Inversion clearly seen in this cross-section. And the inversion is started as early as early Miocene. Previously, the depot center was in the northern area, as mentioned before. So this is the northern area. So that's a depot center, and started to shift to the central part in late Miocene. Okay, so now we are moving to the in situ stress analysis. I'm not going to discuss the vertical stress and minimum horizontal stress, but I'm going to concentrate on the maximum horizontal stress here. So the magnitude of maximum horizontal stress is the most difficult principal stress to estimate in comparison to magnitude estimation of vertical stress and minimum horizontal stress. To estimate the magnitude of the maximum horizontal stress, this study incorporates frictional faulting theory, where the ratio of the main principal effective stress and the minimum principal effective stress is a function of rock coefficient friction, mu. And so using rock coefficient friction of 0.6 for strike slip stress regime, the magnitude of maximum horizontal stress then can be estimated. And the maximum horizontal stress as function of depth can be generated. Okay, now we are going to discuss about stress regime and overpressure main generating mechanism. This is prices. The ratio map, the stress ratio map is dominated by ratio of more than 1. It's a bit small, but it's that's a scale. It's 1 to 1.6. So the study area, the ratio in the study area is basically more than 1, which clearly demonstrates that the horizontal stress magnitude is higher than the vertical stress magnitude. And this confirms that the study area is in strike slip stress regime based on the Anderson faulting method. Yeah, so strike slip. As discussed earlier, the majority of the top overpressure is within the Pleistocene recent interval. So you have horizontal stress higher than vertical stress, and then the overpressure is present also here. But before we conclude that the horizontal stress as the main overpressure generating mechanisms here, we will first validate this preliminary conclusion with the pore pressure prediction. So since we know that the study area is under rapid sedimentation, represented by vertical stress, also is under strong tectonic influence, represented by horizontal stress, and the fact that compaction is a 3D process, the concept of mean stress is utilized in this study, which is basically the sum of all principal stresses divided by 3 to incorporate all of principal stresses. Then we just use the basic Terzaghi principle to get the mean effective stress. So basically the mean stress is minus pore pressure from direct pressure measurement and indirect pressure measurement. And then to generate pore pressure prediction, we then develop the relationships of mean stress as a function of depth, as well as the relationship of mean effective stress as a function of well velocity. And this is an example of pore pressure prediction. So the pore pressure prediction using the original Eaton method that use only vertical stress in blue line shows prediction that is basically underestimate the mud weight, the triangle one here, the triangle data here. So it's underestimate mud weight. Also underestimate the direct pressure measurement. So like the red dot here. So, and however, the pore pressure prediction using the concept of mean stress, where we actually use all the stress component between concept of mean stress and the relationship of between mean effective stress and velocity in red line here provides a better match with direct and indirect pressure measurement. So relatively in a better match with the mud weight here. Yeah, that's an indirect pressure measurement, and also the direct pressure measurement. And so this validates or confirms that the horizontal stress has a bigger role than vertical stress in generating overpressure. And so as the conclusion of this study, overpressure is common in almost all wells in the study area, and in general start at Pleistocene to recent interval. The compressional tectonic activity in the study area reached its peak at Pleistocene to recent interval. The main overpressure generating mechanism in the study area is concluded as tectonic-induced disequilibrium compaction due to very active compressional tectonic during Pleistocene to recent period. So that's based on the quantitative analysis here. The direct application of Terjaghi principle using mean stress and the relationships of mean effective stress and velocity in pore pressure prediction gives a better match with both direct and indirect pressure measurement and validates the prior conclusion. And of course, the accurate pore pressure prediction will significantly improve the plan during preparation and execution stage of all hydrocarbon exploration activity. So that is all of my presentation. Thank you very much for your attention.
Thank you, Pak Sena, for very, very insightful presentation in overpressure in the East Java area. So without waiting any longer, I will give the opportunity for the participants to ask questions. Again, you can raise your hand through Zoom application or chat. Type your question in the chat box, and then I will read it to Pak Sena. While we are waiting, so I've been following your presentation. There is a statement that mentioned there's no common top overpressure in this area, which is ranging from anywhere from several hundred meters to 1,500 meters, I think, if I remember correctly. Why do you think is that? Is there any geologic argument behind that? Is it a structure or something that you may try to interpret as the cause of that difference in top of overpressure?
Okay, thank you, Mr. Chairman. Let me go back to the cross section here. Okay, so this is, I guess, a good representation of the structural geology of the study area. So as you can see, here's the Pleistocene, and this is the recent, I can say that's a recent interval here, Pleistocene to recent interval. So you can see that the Pleistocene, that's because of the uplift. So you have an erosion here. So some of the top overpressure getting really close to the shallow depth here. That's because of the uplift. So that's why there is a difference in the depth of the top overpressure. Is because of the strong uplift in the that affected the study area. So I guess that's the simplest way to answer that. That you have really a strong uplift in the study area, and that's because of the inversion.
Okay, got it. So for the overpressure zone itself, is it a hazard for drilling, or is it a blessing for seal rock for hydrocarbons, or is it both?
Okay, so basically, this is more first. It's more on the hazard side. Reason for that is because you can see that the top overpressure is very. You can encounter the top overpressure or the starting point of overpressure at the shallow depth. It means that you have to be really careful at the beginning of your drilling activity, because again, usually the interval on the early part is mostly still using a long interval of drilling on open hole. Here you have to be really careful, make sure that you can identify the top upper pressure easily, so you can really manage the mud weight for the drilling readily. So that's the most important aspect on this drilling, and of course, early planning of this drilling, incorporating the information of this overpressure, that will give really a good timing, a good planning in terms of cost, and the most important is the safety itself for the operation. So that's the important stuff.
Okay, very good. Thank you so much, Pak Sena. I will still have several minutes for question and answer before we proceed to the next speakers. But if you do have questions, please do not hesitate to ask the speakers, later, through emails or through other means of communications.
Yes.
Okay. With that, please give a big round of applause for our speakers, Pak Sena Exalagora. Terima kasih, Pak. Thank you.
Okay.
Also, maybe I have forgotten. Thank you too, and applause to Bari and Professor Eddie for the previous talk. And we will now proceed to the last speakers of the session. Mr. Devito Pradipta, are you here?
Yes, Mr. Rinaldi, I'm here.
Okay, so we still have until 12:30 actually, but the allocation for your timing is around 20-25 minutes. So please give your presentation within the time frame, and then we will have a lunch break before proceeding to the afternoon sessions. Okay, for Mr. Devito Pradipta, time and place virtually are yours. Please proceed to your presentation. Thank you.
Okay, thank you, Mr. Ray. I'll share my screen. Is it clearly now? Is it clearly seen now?
Yes, it's already showing now.
Okay. Good afternoon. My name is Devito Pradipta. Ladies and gentlemen, hope you're doing well and in a healthy condition. My name is Devito Pradipta, and now I'm representing myself for today's session titled Identification of Volcanic Hydrothermal System based on the integrated study of volcanic stratigraphy, structural geology, and fluid chemistry in Southern Huddersfield, Indonesia. And hereby, now I am representing my co-authors, Mr. Yantini, Mr. Alvin Rudiawan, Mr. Deddy Kusnadi, and Mr. Lano Aditya Permana. And this is the brief profile of me. I'm a master student of Geological Engineering, Institute Teknologi Bandung, and you can contact me anywhere you want if you wish. And this is my co-authors, Mr. Yantini, Mr. Alvin, Mr. Deddy, and Mr. Lano Aditya Permana. And from the presentation outline, we will start an introduction, then we will continue for the data and methods, and we will continue into geothermal systems of Southern Huddersfield. And now we are close at the closing of my presentation. Background of my study that in Southern Huddersfield is really necessary to be continued for more detail, as it was previously done by JCHA in 2000 and 2001 in the regional scale, so that it really needs for a more detailed study, and hereby we can see there are many clusters of manifestation associated with some of the volcanic landforms here, such as remnants of intracaldera volcano Volupio, and Age caldera shows hot spring here. And also in the western side of the research area, we can see a cluster of manifestation associated with Bena volcano and cinder cones. And yet, the geological structures in the research area is barely considered and studied as the permeable pathway, barrier, or system boundaries in southern Gada field. The objective of my study is to identify types and characters of geothermal system in southern Gada field based on volcanic stratigraphy, structural geology, and fluid geochemistry of geothermal manifestation which located in several volcano clusters. And my study is to generate a conceptual model of geothermal system in southern Gada field. My research area is located in Flores Island, administratively located in Nada District, East Nusa Tenggara Province, with total area of 64 km square. And administratively, it is located 20 kilometers in the southern part of Bajawa, in which the capital of Nada District, East Nusa Tenggara Province. And data methods here, I'm starting with the literature study, and I found that the southern Nada field is necessary to be studied in more detailed area as one of the volcanic geothermal system. Then I compiled for the geomorphological analysis to find that there are volcanic clusters in the research area that is associated with volcanic landform, and hereby I will convince the research that it is comprised of three different systems through volcanostratigraphic analysis, fluid geochemistry sampling, and also hydrology. And here, in each of the results, we can compile that there are Nage cluster. It is associated with its volcanic products and so on. For fluid geochemistry, says the different results, and also hydrology, which is then validated with structural geology and conceptual methodology generation. As in the regional geology, southern Nada geothermal field is part of Sunda Bandar volcanism in Flores Island. Flores Island was once part of amalgamated Argoland to Eurasia in late Jurassic to Paleocene. The collision occurred twice as emerged spur caused counterclockwise rotation of the island. Nowadays, Indo-Australian plate moves relatively north-northeast to Flores Island and occurs as a contractional tectonics nowadays. And now the most of the landforms and geomorphology in the area is comprised of the volcanic products, which is consisted of younger volcanism of the Iniria volcano and remnants of older volcanism in forms of crater, caldera, and syndicones. And here we find that there are three volcano clusters in which geothermal manifestation located. In the middle, we find there is a Nage caldera and intracaldera associated with Nage cluster. And the western side, we find Kelly Bena cluster associated with remnants of Bena volcano. And in the northern part, we can find this Woloputi cluster associated with cinder cones. And we can see in the conceptual of the volcanic geothermal system, the conventional one, research area is located on an active magmatic arc. So it is supposed to be the presence of the volcanic geothermal system. The remnants of volcanism as indication of heat source may be in form of caldera, superficial, or lava dome. And hereby, from this start of the thinking, we might be conclude that there may be three different geothermal system in the research study based on its cluster and association with the volcanic landform. Under the volcanic stratigraphic concept, we find there is a volcano as a youngest volcanic product, and also the volcanic products therein, we can see, and the Iniria volcano remains the youngest volcanic products here. And Nage hot spring here, we find in the middle of the study area is associated with Volupio and Nage caldera volcanic products, while in the western side, we see that Kelly Bena hot springs in Kelly Bena cluster associated with Bena volcanic products. In the northern side of the research study area, we find that Woloputi solfatara is associated solely on the cinder cones volcanic product unit. In the conventional of the fluid flow volcanic geothermal system involves magma as a heat source from remnant volcanism, so it has relatively high temperature. As this is the assumption we use in my research study, and hydrothermal fluid here will enrich by magmatic volatile from the magma residual hydrothermal and it will mix with the meteoric water, which is ascend through the permeable pathway there. And by those mixing process, we can see there's a relationship of the fluid composition nearby the heat source, and as the increasing distance, it will also shows relationship with the fluid geochemical composition. Acid sulfate water and solfatara is commonly found near the heat source, while chloride and sulfate bicarbonate water could be found in increasing distance. And hereby, in the geothermal manifestation appearance, we can see in the Nage cluster, there is Nage 1 and Nage 2 hot spring, which is range to 30 meters width, clear, smells of sulfur is found, but no taste and no bubble identified. Another geothermal manifestation shows similar characteristics, but with the more narrow size. And in the northern part of the study area, we see that the Wolo Putih Solfatara shows there's a crystal of sulfur. Hence, it indicates there's a active magmatic forming the hydrothermal system in northern part of the study area rather than the southern part. And here, it turns from fumaroles into the Solfatara. In the fluid geochemistry, it shows the enrichment of various elements, which is correlated with the process occurred in the fluid flows from subsurface into the surface manifestation. Fluid manifestation shows presence of mixing between magmatic, hydrothermal, condensate, and meteoric fluid, as shown in the table in the left side. We show there is an enrichment of silica, aluminum, iron, and all magnesium, and so on. And it indicates that there's mixing between magmatic and hydrothermal fluid source into the meteoric water only. And also, there's a Kelly 2 and Bena shows mixing between condensate and meteoric fluid, as shown here, like a composition of sulfate and the magnesium. And to prove that my interpretation, I plot to the conventional triangular diagram, and it shows that Nage 1, Nage 2 in the Nage cluster shows the volcanic water, and in the Kelly Bena hot spring in the Kelly cluster, there are volcanic water manifestation and also condensate water. And also in the middle triangular diagram, we can see that the Kelly cluster, Nage cluster shows the same reservoir, and Kelly Bena cluster shows different reservoir with Nage 1 and Nage 2. And the last of the triangular diagram, we can conclude also that all meteoric water is ongoing mixing with the fluid geothermal manifestation, as it shows immature water, which indicates the fluid mixing. And after we conclude the geothermal manifestation geochemistry, and now I try to emphasize the reservoir depth estimation based on the database of geothermal exploration well in Indonesia from 1970 to 2008. Hereby, we can conclude that Nage system, Kelly Bena cluster, and also Wolo Putih cluster shows different elevation of reservoir. And if we conclude in a hydrologic cross-section based on the such estimation of reservoir depth, we can conclude that system of Kelly cluster and Nage cluster and also Kelly Bena cluster shows different hydrological pattern. So it emphasizes that there's a difference of fluid flow and hydrological flow pattern, and such hydrological flow patterns with its difference will emphasize to the different system of geothermal system. Another section from the Kelly Bena system to Wolo Putih Solfatara shows another different system of hydrological pattern. So we can clearly a bit convinced here that Kelly Bena, Nage, and Wolo Putih cluster are three different system itself. In the structural geology insights, we find that there are north-northwest and north-northeast strike slip fault, which is associated with tectonic deformation, while normal faults is related to Nage caldera and craters formation through the volcanism activity. And here we can see that strike slip fault is cross-cut the normal fault, and hereby we can emphasize that the tectonic deformation cross-cut happened later than the volcanic activity. And in the structural pattern, based on its geometrical relationship, F1 fault is interpreted as a regional strike slip fault, which is present as the principal deformation zone and so on. There are antitectic structures, and there are fault 8, which is associated with extensional structure, which controls the presence of the regional lineaments of cinder cone. If we conclude all the study I have emphasized here, we can conclude that configuration of F1 fault creates permeable pathway which came out as Nage1 and Nage2 hot spring in Nage system. F1 fault is related to the deep-seated fault, as the Nage hot spring is associated with chloride sulfate water, which derived from the reservoir for depth. And in the Kelly-Bena system, we can see that fault 2 is more likely to be deep-seated fault, and F6 should be the thin skin fault, which control the permeability pathway for the hot spring manifestation in here. And F3 here act as a very prominent role, as it barriers the fluid flow for each system, and it became the boundary system of system Nage and system Kelly-Bena. Another conceptual model is made through the Kelly-Bena system and Woloputi-Solfatara. Fluid flow in Kelly-Bena system is bounded by F2 fault in NBNA crater, while Woloputi-Solfatara is more likely to be in another separated system. F10 fault in Woloputi system act as permeable pathway for magmatic gases to ascend as Solfatara through the extensional structure. And based on the conclusion of my study, the integrated of study of volcanic stratigraphy, structural geology, and fluid geochemistry of geothermal manifestation, we can prove that there are 3 different geothermal systems in the study area, which is associated with Nage caldera, craters, and circum volcanism. Nage1 and Nage2 hot springs are volcanic geothermal manifestation associated with their Nage caldera and Wolopiu craters and volcanic product unit. And also Kelly-Bena system is associated with geothermal manifestation located in Bena volcanic product units, and Woloputi-Solfatara associated with zircon volcanic products. And we can see this, and the F1 fault acts as a permeable pathway and likely to be deep-seated fault, which F2 act as a permeable pathway for Kelly-Bena system, and F10 act as a permeable extensional structure for cinder cone. And hereby we can see there's structural geology which act as the boundary of the its system in my research study. And I recommend that from the present study, further exploration methods are necessary to be done in southern Ngada field to prove the presence of all systems. Furthermore, boundary of a system has to be delineated. Hydrothermal alteration study could be done to identify the presence of heat source from active and fossil geothermal system. Geophysical surveys, magnetotelluric here, also could be done to determine the presence of magma as heat source. I would like to acknowledge the Center for Mineral, Coal, and Geothermal Resources Geological Agency, Ministry of Energy and Mineral Resources, Republic Indonesia, for the opportunity for field data collection and access of data to support this research. And this is the end of my presentation. I would love to thank you to all the audience, and I would happy to have your patience. Thank you.
Thank you. Thank you very much, Mr. Devito Pradipta, for your excellent presentations about the geothermal fields. Yeah. So without waiting any longer, I will open the opportunity to the audience for asking questions to Devito. Okay. Yeah. Maybe while we are waiting for the audience to convey their questions, I probably missed your presentation a little bit, but I would love to know how you map the faults. What method you use to map the faults?
Yeah.
Is it surface structural geology method or how? Yeah, please explain.
Yes, thank you, Mr. Ronaldi, for your question about my research. And hereby I compile my structural geology. I'll do it by field mapping. So I divided. Actually, I was dividing my research area into some grids. Then I tend to make a traverse like a conventional method, but I tend to classify how is the orientation of each grid. Then I can see how is the pattern, and I also classify all the fractures which is associated with each of the fault. And then I do the conventional kinematics, and also previously I already do the remote sensing analysis from the DMNAS image to make my interpretation of the fault easier to detect which is fault and which structure might to be the prominent sites to be visited, and what is their implication for the system. I could predict it from the Demnas image.
Okay, then you make the cross sections, right?
Yes.
And is that so? How do you interpret like the projection to the subsurface? Is it like based on the surface mapping for like strike and dips or something like that?
Yes, thank you, Mr. Rinaldi. This is how I made the conceptual model. It's same. It's the combination of volcanic stratigraphic mapping, and from the volcanic stratigraphic mapping, I map all the surface distribution of the volcanic products. Then I have to determine where the volcanic products is sourced from, and then I compile it all and into a conceptual model, and also I doing a kinematic analysis for the fault orientation and about the isothermal and fluid flow. It was came from the geothermal geochemistry fluid, and also the isothermal came from the empirical calculation, mathematical calculation from the database.
Okay, yeah, because like for example, that just on the right side of the picture, there's like in a bit intrusive section that you put question mark there. Is it what it is based on?
Yes, thank you.
You know that the QPI or something like QPI, I think, or
yes, QPL.
QPL,
Actually,
yes.
Yeah, the question mark I pointed here is belongs to the something that it needs to be validated more, but I already predict something. For example, this isothermal should be ended here, so I put a question mark here, and it needs to be validated whether it is continued ghost flow around or it is bounded by the F3 faults. And also here, KPL, this is a KPL volcano conduits, maybe this, and I have to put a question mark because it needs to be, it needs further exploration methods to know how deep it is.
Okay, I got it, because there's still lots of question marks here, yeah, in the subsurface. So maybe a subsurface method like you recommend in the end is good to validate your interpretation here.
Yes.
Yeah, and there's a comment from Professor Benjamin Sapi that thin skin is a term used for truss fault system only. So you might want to consider the comment from Professor Mino. So, okay, is there any other audience here that would like to give Devito questions, would like to ask him before we conclude this session? Last call. Okay, all right. If we don't have any other audience to ask questions, thanks again for Devito for the presentations. It's very very insightful for us. Please give Devito and previous speakers big rounds of applause for this first
Mr. Benjamin.
parallel session. So you will have around 1 hour, maybe more, 1 hour 15 minutes until the next afternoon session, the keynote with Professor Josaphat. So again, I would like to thank you all here, presenters, speakers, and the audience that spending your time to attend this parallel session. I will see you again very soon in the afternoon. So please have your break. Thank you so much, and stay safe and healthy. Thank you.
In this session, we will have talks from two our invited speakers. So we will have Professor Edi Aryono Subroto and Dr. Eka Junarsyah. Both are from ITB, but Dr. Eka will be represented by Gabriela Alodia, PhD. And after the two invited speakers, we will have three other oral speakers who will be deliver diverse topics in natural resources. So before we start our session, I would like to remind all participants to set off your microphone during the lectures. And if you have some questions, please raise hands or post them in the chat feature along with your name and institution. So we will be running a live Q&A session after the talk. So now I would like to ask all participants here to kindly turn on your camera. So we will take some pictures for documentation. So I will try to put in this view. Okay, I will wait for a moment. Once again, maybe for all the participants, please turn on your camera so we can take a picture together. Okay, I will take the picture on the count of 3. 1, 2, 3. Okay, thank you very much. Now I would like to invite our first invited speaker, Professor Edi Aryono Subroto, who will give a presentation entitled Refilling Source Rock in the Bintuni Basin, Papua Island, Indonesia, based on geochemical analysis. So good afternoon, Pak Edi. Professor Edi Subroto is a senior lecturer in Geological Engineering Study Program ITB and the head of Petrovolcanology and Geochemistry Research Group in the Faculty of Earth Sciences and Technology ITB. His field of expertise are petroleum geology and geochemistry, and he has been published hundreds of publications or more as books in various respects and publishers in this field. So without further ado, you have 5 minutes for presentation. We will have afterwards 5 minutes discussion. So Pak Edi, time and place are yours.
Thank you very much, Mr. Professor. Good afternoon, ladies and gentlemen. Please allow me to share my presentation. Well, I hope you now can see my slides.
Yes, Pak.
Okay, yeah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. In this occasion, I would like to present my paper entitled Refilling Source Rock in the Bintuni Basin, Papua Island, Indonesia, based on geochemical analysis. And as mentioned by Mr. from research group, namely from volcanology and geochemistry. My presentation topics consisting of 5 from introduction into the conclusions. Now for the introduction. This is the background. Exploration in the area is fairly limited. First exploration was recorded, even though that's so long ago, in 1935, but mainly from the petroleum companies, not from the local petroleum company. That's, for example, from NNGPM, from Royal Dutch Shell, Stanford, and also from Caltex. So this research is located at the birth head of Papua Island, Indonesia. Well, I believe that you all know about Papua, but because this one is set for international seminar, so I prepare to show you the Indonesia. To those who are not familiar with Indonesia, this is the map of Indonesia. And the Bintuni Basin is around here in the eastern part of the Indonesia. If I would like to enlarge the map, this is the enlargement of Bintuni area and surroundings. Some wells whose sediments and crude oil samples are shown in this side. It can be seen that the well's location is both onshore and offshore. Let's go to the samples studied. Actually, there are 2 kinds of samples studied in this work. One is the sediment samples and the other one is the crude oil samples. We did 79 samples from 26 wells and 7 samples from 7 wells for the crude oils. And the geochemical analysis done were the TOC determination for the sediment. For the sediments, there are three experiments. That's for TOC determination for knowing the source richness, rock eval pyrolysis. That's for source as well as for maturity and also for the source of organic matter, vitrinite reflectance for maturity of the sediments. And both sediment and crude oils, we did the experiments for 3 kinds. That's the carbon isotope, GC, and GCMS. 3 clusters. If you know about the petroleum geology of Papua, usually or basically 3 clusters of promising source rocks in the Papua island. First is the Koli terrestrial shales, usually from the Ainim formation, with the geological age late Permian. Koli marine shales from Lower Kembelangan formation, that's early to middle Jurassic, and finally marine calcareous claystones from Waripi formation, that is tertiary. So actually this is very complex. There are some source rocks from tertiary as well as from the pre-tertiary. This slide shows distribution of tertiary basin in Indonesia, published by BPMIGAS. That's the old name of nowadays called as Kakamigas, the Indonesian Agency for Upstream Oil and Gas Business. And this maps, if I'm not mistaken, published in the early 2000. This map is very friendly, therefore I prefer to use this one rather than the newest one published by the other official agencies. Of course, information in this map maybe is not very accurate at the moment, but I believe that even though if there is a difference, the difference is not that significant. In this map, you can see that actually there are at least 60 tertiary sedimentary basins. With the classification, 15 producing basins, that's the blue one, 9 basins with the discoveries and producing, the red one, 14 drilled basins, no discovery, yellow color, and last, the green one is undrilled basins, which there are 22 of them. Well, if we see this one, actually we still have hope that at least 22 basins are undrilled. And this is the location of the Bintuni Basin, which is classified as a producing basin. The aims of this study, first, there are 3 at least. The first is to demonstrate the use of petroleum geochemistry to evaluate source rock capacity, and the second one to correlate between the crude oils and source rocks in order to try establishing the source rocks or rocks that is or that are responsible for the occurrence of hydrocarbons in the area. And the third one, hopefully, I can answer the multiple choices question, which one is the source rocks of the Bintuni Basin. Oops. Yeah. Next is the source rock evaluation. In this study, sequence stratigraphy has been applied. So source rock evaluation discussed based on the sequences. There are at least 6 sequences in the stratigraphic column of the Bintuni Basin based on paleontology and palynology studies during our work several years ago. This is the stratigraphy column of the area, and this is produced by or provided by our geology team. The stratigraphy can be divided into 6 sequences. If you can see this one, number 1 up to number 6. Number 1 is the early Permian up to late Triassic sequence. Number 2 is early to middle Jurassic. Number 3, late Jurassic to early Cretaceous. Number 4, early to late Cretaceous. Number 5, Paleocene to Oligocene, and number 6 is the Oligocene to Miocene. Now we come to the results. Of course, the geochemical result, the gas. Here. Now we come to a cross plot that indicate source maturity. Again, the samples shown in the slide belong to the sequence 1 group. The maturity parameter used here is what's so-called Tmax. And again, Tmax is produced by the rock eval apparatus, the same as the S1 and S2 discussed before. Threshold for sample, if the sample can be set to enter an oil window, is 435 degrees centigrade. So if you see in the bottom here, the line or the boundary of 435 degrees centigrade, that is the threshold of the maturity. So if I give a box about the maturity, this one is a representation of the mature samples. So in general, 435 degrees centigrade is equivalent to around 0.6% vitrinite reflectance, as we will discuss in the next slide for the vitrinite reflectance. This slide shows maturity assessment based on vitrinite reflectance. In the previous slide, I mentioned that the oil window maturity generally starts from 0.6% vitrinite reflectance, or symbolized as RO. If we do a plot between RO data and depth for sediments in the study area, it is quite clear that maturity of the samples in the area starts from sequence 3 around here. Actually, sequence 3 samples still belong what so-called transition zone from immature to mature. So in more detail, the maturity assessment will be shown in the next slide. So this is the summary of the maturity. You can see here that the mature oil, actually the whole mature oil started from sequence 2, and of course sequence 1, the older one. While the sequence 3 up to 6, that's the transition between immature and oil window. Next is the correlation study. Correlation has been done using carbon isotope and biomarkers. And for the biomarkers, we use triterpenes and steranes. Luckily, this one has been mentioned a little bit by Barry in this morning session. So I don't need to explain further about the biomarkers. The key factor for correlation is the presence of or absence of oleanins. So in this case, I just would like to demonstrate the use of oleanins and the importance the use of oleanins, because a few weeks ago, I also had a project discussing about the absence and the occurrence of oleanins. If you are not familiar with oleanins, oleanins have been believed as a remnant of flowering plants or angiosperms flourishing during late Cretaceous around 70 million years ago. Basically, crude oil samples in the study area may be divided into 2 groups. Group or family 1 is the samples contain oleanins, and the family 2, those with oleanins absent. The problem is with the oleanins that are biomarker for tertiary age. Actually, the samples having oleanins are actually also in a good match with the pre-tertiary sediments. So if I did the correlation, the 2 families actually well correlated with the source rock, sequence 1 and sequence 2. Both sequences belong to the pre-tertiary geological age. Now, actually there is a big problem because oleanins, as I mentioned before, has been believed started to flourish after late Cretaceous. So that is impossible to have oil that could be correlated well with samples from pre-tertiary samples, with pre-tertiary sediments. So therefore, this is our duty or my duty here to explain what happens actually. If this is the mass fragmentograms of a representative oil sample from Bintuni Basin. More specifically, this is MONZ191 fragmentogram distribution of triterpenes. One thing that I would like to point out in this figure is at this point with the blue arrow over there. That is the retention time or the place if oleanins occur. That's very close to the highest one, number 6 here. Number 6 is the C30 hopain. So oleanin and 30 hopains are close all together. In this case, I would like to demonstrate that in this sample, no oleanins. So this example is actually belong to family to crude oils which are without oleanins content. So if you see this one is in this study. I put this sample belong to the family 1 samples that crude oils with oleanin. Let's have a look more closely in the oleanin detected in these samples. If you can read this one, the authenticity of the oleanin peak has been cross-checked in this study by observing the corresponding MONZ 369 fragmentogram. That is, there are 3 two actually, there's 191, there's the same 191, and this one is MONZ 369. In general, oleanins do not produce a peak on the MONZ 369 scan. But for this DST sample, a peak is observed on the MONZ 369 scan, which matches that on the MZ 191 fragmentogram. If you see this line, that's exactly in the same place. So this implies that another unknown compound having a C30 hopanoid structure is co-eluting at the same retention time as oleanins. The next correlation using the carbon isotope. So carbon isotope is also used in this work. This is a cross plot between delta C13 saturate and aromatic fractions. According to theory, oil isotope is around 2 per mil lighter than that of source rock. Thus, looking in the plot, it is apparent that sequence 1 source rock oils indicate good correlation with the crude oil relatively correlate well. In this case, in particular for Permian source rocks. 2 crude oils here with the red circle appear to be different with the other samples. So this is actually our trick to prove that there are correlation between crude oils and the Permian samples, but we would like also to explain why there are some oleanins in this case. As I showed you before that actually this one is not real oleanin because the real oleanin has no 369 MZ, has no peak in the MONZ 369. So therefore, actually this one is not oleanin. So when this is not, we can prove that this is not oleanin, then we can, there is no problem with the correlation. So in summary, the organic matter contained in the source rocks as well as in the crude oils predominated by a mixture of higher plants and shallow marine lacustrine materials. Correlation tends to point out to the Permian source rocks. Finally, I would like to discuss a little bit about geochemical modeling, because we did also the modeling to prove that the Permian Permian source rocks are the rocks that could yield crude oils. This one, 1D modeling has been done using basin mod software, and this modeling was done to illustrate and as a backup for the results displaying that the sediments belong to the sequence 1 and 2 are mature in the whole Bintuni Basin. This is for the sequence 1. Sequence 1, sediments are mature with critical point at around 260 million years ago in the late Permian. So this sequence 1 started to produce oil a long time ago, 260 million years ago, while the sequence 2 sediments are mature with critical point at around 75 million years ago in the late Cretaceous. So the modeling also support our previous conclusions that the two sequences may produce hydrocarbons. Finally, we come to the conclusions. All oils are mixed, marine and terrestrial to fully terrestrial, fluvio-deltaic organofacious. There are two oil families. So I put quote and unquote two oil families. Actually, there's only one family, one containing oleanins and the other with no oleanins. However, the authenticity of the first oil family should be re-examined because of technical analysis problem, as I mentioned before. The one without oleanins suggests that the crude oils were derived from pre-tertiary source rocks. Sediments that can be relatively good source rocks around the study area are abundant, as I showed you before about the source richness in terms of the richness, organic type, and maturity. So finally, it is most likely that petroleum source rocks are the pre-tertiary rocks, the Permo-Triassic or sequence 1 sediments, and they seem to have generated hydrocarbon. So actually that is the answer. And last but not least, I would like to acknowledge as Kakamigas, Professor Benyamin Sapii for inviting the author to join the project, and Dr. Asep Kesumajana for providing the 1D basin modeling. Thank you very much for your kind attention.
Thank you very much, Pak Edi, for the very clear and interesting, so as insightful talk. So I would like now invite all the participants to pose your questions. Maybe you may raise your hand, or you may also write your questions in the chat features. Okay, maybe while waiting, Pak Edi, before you mentioned that there was a palynological study conducted in this area. So could you please tell us a little bit about this study, especially relating to the source rock to oil correlation?
Yeah. I don't know what you mean with the source rock, and because what I discussed before, that's the correlation actually between source rock and the crude oil, and the results indicate that the sequence 1 and sequence 2. So if I would like to show you again the oops. Yeah, if I would like to show you again the stratigraphic column here. So this one is the sequence 1 to sequence 2, that's the early Permian to late Triassic and the early to middle Jurassic. So if I further explain about this one, in the two group of geological ages, it's supposed to be not, we cannot find the oleanins, but in the samples, we can find oleanins, and we can actually correlate well between the oil samples and the early Jurassic and early Permian source rock. So that's actually impossible. If you know about the flourishing time of the oleanins, that is in the end of the of the Cretaceous. So it is impossible. So therefore, I have studied detail about the oleananes contained in the samples. And luckily, we found that the key factor is the M onset 369, because in the general fragmentograms of oleananes has no peak in the M onset 369, and this one has 369. So actually that is not an oleanine, but something that is C30 triterpene, but placing or in the place of oleanine. So if back to your question, actually the correlation is between the early middle Jurassic, that's the sequence 2, and the sequence 1, but especially the sequence 1 has a very good correlation with the crude oil samples in the basin.
Okay, thank you, Pak Edi. So the correlation is strictly based on the biomarker, ya, Pak? Without
The
any
biomarker.
palynological constraint. Okay.
Oh, no. That's not my field. I will need
I
your
thought I will.
help if you sit down.
Okay, thank you very much, Pak Edi. But maybe a little bit more questions developed from your answer, maybe. So, using the biomarker oleanin, we can only evaluate the source rock that are rich in terrestrial organic matters, or can we use it also to another marine source rock, for example? Or
well, that's a good question, actually. When I did my PhD back in the 1985, at the time, my supervisor didn't believe that oleanine could be used in the marine samples. So at the time, there was a paper wrote by Rudy Foer saying that because of the oleanine found in the marine samples, he mentioned that the source of the organic matter from terrestrial. My supervisor didn't believe that. It's impossible because oleanine is one produced in the higher plants, which is mean terrigenous, terrestrial. But after that, he could believe this one because actually oleanine, that is a strong organic matter. So it could be produced in the higher plants, but it could be transported up to marine without any degradation. So that is the problem. So that's we prefer to explain that not marine as such, but the organic matter came from terrigenous but transported into marine.
okay, well, very clear, Pak Edi. Thank you very much.
Yeah.
Now we have some participants here. Maybe Mas Bari, you may open your mic and pose your question.
Hello, ladies and gentlemen. I would like
thank you very much for the opportunity, Bu Maria, and thank you very much for the very interesting talks. Pak Edi, we always discuss about oleanine oftenly, and I have two questions. A simple questions. My first question is, I just wonder what is your samples in the study for the oil. Is it oil stain or migrated oil or drill stem test? Because I'm afraid if I saw there is some possibilities from the extract from the rocks in the samples. That's my first question, Pak Edi. And my second question is, it is a common question from geochemists. We believe that each biomarker are sensitive and have a different sensitivities in each basin. And according to Pak Edi, which biomarker are sensitive in Bintuni Basin? Because based on your presentation, I see that Pak Edi is using more the pentacyclic terpene, different with me that usually use tricyclic terpene despite of the pentacyclic terpene. That's my questions, Pak Edi. Thank you.
Thank you very much, Barry. Yeah, this is very good question. Actually, if you see this one, that's for the DST5 sample. So mainly the samples studied here are from really crude oil. So that's not the stain or the migrated oil. So that's from the DST. So that's oil. So well, therefore, I don't, not I don't care, but I don't think about the extraction. So because of the extraction, it could be that will be a mixture between oil from the inside to rock and also oils from the stain. But this one is TST. So that's real crude oil. That's the first question. The second question is, well, I also sometimes or many times or often use the tricyclic terpenes. But in this case, the key is the oleanins because the clusters, some people clusters the crude oils over here into two families, family 1, family 2, family 1 with the oleanins and family 2 without oleanins. But if we correlate the two families, the two oil families with the source rock, it's matched with the pre-tertiary samples. So there must be something wrong with the oleanin. And luckily, we've got the key that 369, I don't know whether the new one, but one is the Naitov et al., that's 2010. He mentioned that Naitov, they didn't see M-onset 369 in the oleanin. So if there is 369, M-onset 369 with the oleanin, quote and unquote, it must be not oleanin. So because of that, I use pentacyclic, but tricyclic sometimes also very useful. So you can depends on the case, Barry.
Okay, thank you, Perry, for your answer. Thank you very much.
Okay.
Thank you, Pak Edi and Barry, for the questions. So the next question is maybe from Pak Ray. Pak Ray, please unmute
It's the boss.
pose your question.
Boss asking.
Thank you so much, Professor Edi. This is very interesting and very insightful presentation because this is a hot topic. So maybe from a general audience point of view, I would just like to ask a very simple question. So could the presence or the absence of oleanins indicate whether or not the source rock is pre-tertiary?
It could be yes, it could be no. The occurrence or the presence of oleanins, that's exactly indicate that the samples must be after Cretaceous. So it means mainly tertiary samples. But the absence of oleanin could be two things. Yeah, the first thing is because the what's so called the paleo development, the paleo what's so called that
Paleogeography or paleo environment?
Environment, yeah. Environment, so the development. The paleo environment is far away from the flowering plants. So, of course, there is no oleanins in the samples. The second one is because of the pre-tertiary. So, actually, that's the thing. The occurrence could be indicate the tertiary samples, but the absence doesn't mean belongs to the pre-tertiary. It could be tertiary, but the condition is far away. The paleo environment is far away from the flowering plants. So therefore, in this case, geology people are needed because, you know, by doing what's so called the paleogeography, and then we will know that that's far away from the source or no.
Thank you very much. Very well understood. Thank you, Professor.
Okay.
Well, thank you very much, Professor Edi, for the talk and for all the knowledge and for all participants for the discussions. Maybe due to the time, I would like now to proceed to the next invited speaker. So now I would like to invite our next invited speaker, Gabriela Alodia, PhD. So good afternoon, Bu Gabi.
Hello, Bu Maria. Long time no see.
Yeah. All right. Okay. So, Bu Gaby is one of our lecturer in
Good afternoon,
Geodesy and
ladies and
Geomatics
gentlemen. My
Engineering
name is
Study Program
Gabriela
in
Aludia,
ITB
or you can call me
and a
Gabby.
member of Hydrography Research Group. So, in Faculty of Earth Sciences and Technology. She got PhD from University of Leeds. In marine geophysical data acquisition and processing. And now she will deliver the talk entitled Hydrographic Knowledge, a Balancing Act Between Natural Resources and Sustainability. This talk will be delivered in a video, and we will have 5 minutes time for discussions after the talk. So please, maybe Mbak Indah, can you help to start the video now? Thank you.
Good afternoon, ladies and gentlemen. My name is Gabriela Aludia, or you can call me Gabby. I'm here on behalf of Dr. Eka Junarsyah, the head of Hydrography Research Group, Faculty of Earth Sciences and Technology, Institute of Technology, Bandung. And today I'm going to present to you a talk that is titled Hydrographic Knowledge, a Balancing Act Between Natural Resources and Sustainability. This talk is going to be more popular and less technical because, well, we think that this is a very, very interdisciplinary seminar. We do not want to talk about something that is a lot more technical than it should be, because hydrography itself, maybe that's something that is not quite familiar for everybody. So what we are trying to do here is to introduce the importance of hydrography in both natural resources exploration and exploitation, as well as in sustainability, because, well, nowadays it seems like these two are a very polarizing opinion. When we're talking about natural resources, we are talking about something more about exploration, exploitation. How do we actually use these natural resources? How do we find them? How could we make ourselves sufficient with the natural resources? Maybe something that we have, or do we need to make it sufficient by buying from someone else or some other country? And when we're talking about sustainability, we're talking about how to keep this environment intact, how to sustain our life as well, as a human being on Earth, because of course these resources, maybe they have some limit that we did not know, but basically it seems like the opinion would be like natural resources, that's harmful, that's bad. And when we're talking about sustainability, that's good, that's something that they need to do, without actually thinking that, well, these two are the same thing. We are talking about the same thing, but from different perspective. This is why we are trying to make a conversation out of it, especially at least in the oceans or the seas, because that's what our specialization bases. We are talking about hydrography, which is the knowledge of mapping the sea, mapping the ocean, and mapping the waters, basically the lakes and rivers and everything. And that is what we are trying to deliver in this talk. So before anything else, we would like to remind you that the sea is not our habitat. Well, we could never breathe under the sea, right? We could use some tools to enable us to breathe under the sea. We have this dream of having underwater city or everything. But anyhow, human activities in the oceans, in the seas, and in coastal waters, we depend solely on floating or submersible vehicles, because, well, we do not like being wet, we like being dry, we like to be warm, we like to have food, we like to, we cannot work when we are not dry, not warm, or not satisfied enough, right? So that is why we need vehicles in form of maybe boats, vessels, and in these vessels we could also carry a lot of people who we are working with, a lot of equipments we are working with as well, a lot of tools, because these equipments, well, most of them are electronics, right? So we need some place safe for these equipments and for these people to be, to be in place with. And also, we more and more we need submersible vehicles to help us to reach our goals, whether it is for exploration and exploitation, or it's for environmental issues, to actually understand how the seabed looks like, if there is any organisms living in there, and etc. We know something that is called AUV now, the automated underwater vehicle that the cartoon looks like this, basically. It looks like a fish. So another one is the ROV, the remotely operated vehicle. So the difference between these two, the AUV and ROV, is AUV is automated. So there are people who are making programs for this vessel or this vehicle to actually submerge, and then it will navigate, and then it will go back again. It will go back to the surface of the sea. So we just never know whenever an AUV is released, and then we just pray that it will go back. But for ROVs, it's more in our control because it is, well, the name is remotely operated vehicle. So it's a vehicle and you could actually, operate it remotely. So it's easier for us to maybe, well, it's not that easy, but still, it's a lot less complex than navigating with AUVs. But anyhow, each of this vehicle needs something that is called safety of navigation. Why? Because we don't want this vehicle to crash. We do not want this vehicle to, to be in touch with the seabed. We do not want these vehicles to be broken because of, I don't know, coral reefs maybe, or in Titanic icebergs, those seabed features, or maybe not only on the seabed, but also that something that is surrounding the waters. Every single feature needs to be mapped, right? We need to know the depth of the ocean below us, because we want to make sure that the draft of our ship is basically the part of the ship that is not floating, that is under the water. We need to make sure that the draft and the depth of the sea is sufficient. We need to have that space below that draft and the seabed. That is why the sailors in this world navigates with something that is called nautical chart. Nautical chart itself is a map, is a navigational map. You've got the declination of the north in there that looks something like this, because of course you need to know where your north is at the sea, and it contains also features of the seabed that you need to be very, very careful of. It contains some lighthouse features, so you know where you should go. Also features that looks like a harbor or a port. All those features that is important for the sailors to be safely navigating at the sea. And also nautical chart is very, very important, because whenever you're sailing from one jurisdiction to another, for example, from the Indonesian waters to the Australian waters, you need to make sure that the map merge really, really well or seamlessly, because you do not want to have different information from one place to another, right? So that is why nautical charts, beside the paper-based nautical chart, we've got the electronic nautical chart as well. And this is why, because sailing at the sea is very, very international, every single country has their own authority who could produce nautical charts. So not every other person could produce nautical chart. There are some very, very selected people who could actually produce it. So, so you're safe at sea. And the safety of navigation is also implied in the SOLAS, or the International Maritime Organization Safety of Life at Sea. So SOLAS is very, very interesting because, if I'm not mistaken, it was born after Titanic accident. So they do not want to have another huge accident like that anymore at sea. They want to have safety of navigation at sea. That's why they create this convention that is called SOLAS. In the SOLAS itself, the safety of navigation is discussed specifically in chapter 5. So the whole chapter, you're talking about the safety of navigation. That's how important safety of navigation is for everybody who's working or who's basically having fun at sea. Afterwards, we've got more and more demand on good hydrographic survey coverage. Even there are some people in something that is called Seabed 2030. They want to have full seabed coverage of the world by 2030. That's a really, really big dream. But anyhow, the adequate survey coverage has been increased since the first one is the advent of exceptionally deep draught ship. So as I told you before, draught is basically the body of the ship that is sinked under this surface water. So because the ships are getting bigger and bigger, so the draft are also getting bigger and bigger, because you need that, that space to actually contain the weight of the ship and the weight of all the goods that are loaded to the ship. So you need a really, really good map, not only a map of depth, but also a map of the features, and also like maybe the developing features and that in there. Like, for example, if you know that an area is consisted of coral reefs, you need to understand if the coral reef is growing or not, because if it's growing, then maybe it will crash with the boat. If they're crashing, then the boat will not be safe, because it's crashed anyway. It's going to be very, very hard for the navigator to get out of that crash. And also the marine environment, it's actually very, very dangerous for them, because we are not conserving them. They were growing and we are just crashing it. So exceptionally deep draught ship, and also the increasing need to protect the marine environment, because that's basically one of the sustainable development goals, especially number 14. We're going to talk about it, but there's an increasing need to actually protect the marine environment, because we need to sustain our life and land based on the resources that we've got at the sea. And not only two reasons, there are the third reasons. The third reason would be the ever-changing maritime trade patterns, because, well, we truly depend on shipping for delivering our goods, because we cannot depend on planes, because planes cannot, we cannot load the plane with too much stuff, right? But if we are shipping, we could put a lot more stuff compared to what we could put at the plane. And for example, because I lived somewhere in the UK, when I was shipping my my goods back from the UK to Indonesia, it's a lot cheaper to ship the goods than to buy a plane ticket, or a place with a plane for these goods to be delivered to Indonesia, because well, a plane could just have that many stuff, but in a ship you can have a lot more. And then there's a growing importance of seabed resources, not only oil and gas, but also we are talking about exploiting minerals. For example, in the Clipperton and Clarion, there are quite a lot of countries that has concessions in there already. And it's very, very important for these people to know which part is theirs, which part is mine, and etc. And we also talk about the UN Law of the Sea Convention, which is the UNCLOS, because it affects the areas of national jurisdiction. Again, which part is mine, which part is yours, and etc. It needs really, really good seabed mapping. And also the thing that we already discussed before is the SDG 14, or the Sustainable Development Goal number 14, which aims to conserve and sustainably use the oceans, seas, and marine resources for sustainable development, because in fact 3 billion people depending their life on the sea, so we need to conserve it for our future as well. So what do we do as hydrographers, you might ask? Well, hydrography as a science, we collect first-hand data. That's what we do. So this data could be the data of natural resource prospects or the environmental condition and its change over time, because of course, our Earth is very, very dynamic. We are talking about the solid Earth. We are also talking about all the organisms that's living on it. We are talking about the seabed features, maybe the corals are growing and etc. So as hydrographers, we collect this first-hand data. And why is data important? Data is very important because in this way of thinking, the DIKW way of thinking, data, information, knowledge, and wisdom, we could never reach wisdom if we didn't have any data. Right? So the basis of everything is data. You're winning if you've got the data. And data itself is actually only gathering parts. If you could connect this part, then you have information. If you could form a whole from this, from this separated information, then you will have the knowledge. This is what we call hydrographic knowledge. And when we have other knowledge other than this hydrographic knowledge, maybe the geological knowledge, maybe the geophysical knowledge, geodynamics, or maybe something else, we would actually gain a wisdom of how our ocean looks like.
Good afternoon,
right?
ladies and
So
gentlemen.
this is
My name is
basically a very, very
Gabriela.
interesting way of thinking, because when we're talking about data in information, this is what we provide. Every single data that we provide will be something that is from the past, right? Maybe a data that I took today will be something from the past tomorrow. And when we have more data and more information, we could see how our future would be, because we will gain more knowledge and more wisdom. So to conclude our talk today, we would say that great wisdom can only be achieved if it starts with good data collection. And at the sea, if you need good data collection, you contact your closest hydrographers. Thank you for your attention. If you want to know more about hydrography, you could go to our website, which is hydrography in Indonesian, .gd.itb.ac.id, or you could contact Dr. Eka Junasya or me. Have a good seminar, and we hope to have a good discussion afterwards. Bye.
Well, okay, thank you very much for the very interesting talk. Okay, here I would like also to invite the participants. If you have some questions, please raise your hand or post it in the chat features. Maybe while waiting, Bu Gaby, I would like to know the seabed data that has been collected, are they surface seabed data, or they are also collecting the subsurface data?
Yeah, interesting question, Bu Maria. So it really depends on the project, right? Because when we're talking about hydrographers, we are training people who are in the, who are the technical people. So we do learn a little bit about subsurface data, but not as well as the geologists and geophysicists, I guess. But we basically understand every single thing that is collected by acoustic data. So like sub-bottom profiler, like the shallow seismic. We have not been able to go to the deeper seismic, but we're trying to gain knowledge as well from like magnetic and gravity data, because that's interesting as well. And it's quite we often pass those data because we don't, we always want to know what's below the surface. But when we're talking about magnetic and gravity data, we could see faults and we could see everything. So it really depends on what you need. So that's the thing. And I think through the BIG, the Indonesian Geospatial Agency, they're starting to open their data more and more, but it's still on the multi-beam bathymetry, which is the surface data. But that's also I think that's an advancement from our side, because more open data, it would be better for us as well. So we know our ocean more and more, I guess. Maybe that answers the question.
Yeah, very clear. Well, it's very interesting.
Very interesting.
Yeah, really. Okay, well, if there are no more questions from the participants, maybe to be on time, we will continue to our next oral speakers. So, and thank you very much once again, Bu Gaby and Pak Eka.
You're welcome.
So, yeah, now I would like to invite our first oral speaker for this session, Bari Majid Hartono. He's also our master student in Geological Engineering Study Program, who will deliver a presentation entitled New Interpretation of the Nature and Origin of Carbonate-Derived Oil in Seram Basin, Eastern Indonesia. So Mas Bari, you will have 15 minutes for the presentation, and we will have 5 minutes afterwards for discussion. So please, Mas Bari, time and place are yours.
Okay, thank you very much, Bu Maria, for the opportunity. Please allow me to share my screen. So, did my screen appears clearly?
Yes.
Okay.
Okay, thank you very much. Good afternoon, everybody. Thank you very much for joining my presentation, again, entitled New Interpretation of the Nature and Origin of Carbon after almost 50 years. So, a short introduction about me. Currently, I'm a master's student at Geological Engineering ITB and affiliated with several professional organizations such as APG, IPA, SPE, IAG, and FOSI. With my main interest lies on petroleum geochemistry, basin analysis, organic geochemistry, and rare earth element geochemistry. I've already written 17 publications since 2018, and if you are interested to with my research, you could follow me in LinkedIn or my research kit. Before I begin my presentation, I would also like to acknowledge my co-authors. There are Professor Edi Subroto and Dr. Asep Sumajana. Both of them are my supervisors, my thesis supervisors. And then Mr. Roy Andrianto and Mr. Galung Malvinas from Sutik Seram Energy Limited, Dr. Joko Wayudiono from Pusat Survey Geology, and Mr. Bagus Priyanto, a PhD student at Geological Engineering ITB. So the presentation outline today, I will discuss about the rationale, the background of the study, and then we want to popularize the organofacious concept and what is the organofacious concept is, and then the data and methods, how many are samples, and then how the samples are taken, we will discuss it, and then result and discussions, and we close it with summary, and we want to have some further challenges on the proposed, newly proposed petroleum system for Seram Basin. So Seram Basin is a petroliferous basin situated in eastern Indonesia here. If in Pak Edi's presentation before, Bintuni Basin have been drilled in the 1935, the Seram Basin, oil exploration in Seram Basin is relatively more older in 1905. And previous geochemical studies have pointed out that crude oils in Seram Basin belongs to one family that possibly derived from Triassic, Jurassic marine carbonate source rock, leaving the deep marine carbonate Saman-Saman Formation and Manusela Formation that is still debated today about the source rock capacities. Now, I would like to show that this is the carbonate depositional model from Flugel 2006, and we can see here that carbonate rock itself are vary on its organic matter type, content, and intensity. So carbonate rock could be further divided into several organofacias. Therefore, the study aims to reinterpret the nature and origin of Seram crude oils, especially on the carbonate organofacious controls to the crude oil biomarker compositions. So now, what is organofacious concept? It is actually not a new concept. It is already proposed in the 1980. 5 types of organofacias have been proposed by Jonas 1980 based on hydrogen and oxygen index together with the depositional environment, type of organic matter, and the internal structures. And for this study, we adapt organofacious definition from Palakas et al. As the carbonate rocks that have distinctive characters in terms of organic material or organo that encompass type, intensities, composition of organic matter, even the preservation of organic matter that is largely controlled by the depositional environment, include paleobathymetry, as we can see here. This is different depositional model for the carbonate, and I want to give examples. In the shelf, we have a relatively shallower condition, and the organisms will be more algal rich. Compared to the basin, we have a more radiolaria and bacteria rich. If these organisms are die, they will decay and release different biological marker. This biological marker will be recorded in the sediments, and if the sediments expel crude oil, then the two oils will be different. Now, to determine the organofacias in Seram oils, we collect 27 crude oil samples from 4 producing oil fields, Lovin fields, Osale fields, Nief, and Bula fields, and we analyze qualitatively using by comparing the fragmentogram ticks and the quantitative analysis using the quantitative bivariate plots or the ternary plots. However, I will show you that Seram oils data is very complex, so we perform statistical analysis, especially the multivariate analysis. So this is the general oil characteristic of Seram oils. As we can see here, the Seram oils display wide variation in terms of hydrocarbon fraction in terms of saturate, aromatic, and the polar fraction. This variation could be the result of the type of organic matter, the maturity. Both of these factors could be classified as one as a primary controls, and then hydrocarbon migration and post-expulsion hydrocarbon alteration, or the secondary control for this composition. However, we can see that the distribution of the normal alkanes of serum oils is quite identical with the peak below NC22. And then I want to just show this specific biomarker. I know in this room, not all of us is geochemists, so I just want to show the pattern observed in 4 oil samples from Lovin, Ocel, Nief, and Bula. As we can see here, the 4 oil samples have a relatively high dryman and homodryman, and then relatively higher dryman over bicyclic alkane, and then the occurrence of bisnorhopane compound and C24 tetracyclic secohopane, relatively higher C29 over C30hopane, relatively higher TM over TS, and the occurrence of bisnorhopane and hopanoid hexacyclic. That suggests, indeed, all serum crude oils display typical characteristic of carbonate source rock. So the terrain tells differently. There are main distinctive patterns could observe. We can see there is 2 grouping here from the serum oils that I referred this with the red one here is family A, and the blue one here is the family B. And this plot is quite different with the previous PAEDIS presentation because it's already been modified by us, and soon will be published in academic journals. And the relatively significant difference of C29 here could be the result of 2 factors. First, the organic matter input. The second one is maturity. However, the maturity will be eliminated. I will show you in the next slide. And for the organic matter input, the relatively high C29 styrene here could be associated with the terrestrial organic matter input. However, as we can see in the specific biomarker, no terrestrial biomarker are observed in all serum oils. So the relatively high C29 styrene could be the result of other factors or other source of organic matter. Volkmann in 1986 and Nichols et al. In 1990 pointed out that C29 styrene is possibly related with diatom and radiolaria. So we interpret this possibly more in the deeper marine carbonate because there are more diatoms and radiolaria in that environment. And this is the oil maturity. As we can see here, the serum oils display similar maturity in the possibly expelled from the source rock that reach peak maturity. So this is the average. We can see it is still on the same zone. Now, if we are using with the conventional geochemical approach using a basic geochemical bivariate plot, we can see that the bivariate plot here is not effective to answer the origin of 2 different oil family on this terrain plot. As we can see here, both of the oils from the family A and the family B is overlapping. So it is not conclusive. So different approach are needed. Therefore, we perform multivariate analysis, specifically the hierarchical clustering analysis using PAS 3.22 software using Euclidean algorithm. Why Euclidean algorithm? Because Euclidean is the most common algorithm used by geochemists and also the simplest one. And the training set, we perform a multivariate analysis to determine the training set using 24 source-related biomarker parameters. Then the HEA is performed again using all serum oil samples, include the biodegraded samples, and confirm that this analysis divide 2 families in serum basin, which is the family A and the family B. That is, the family B is mostly composed by oil from Lovin. This is oil from Lovin, the red one here. Nief, the green here, and the Ocel field, the blue one. While the family A is mainly composed from Bula fields, the red one. Now, we also found that from the 24 source-related biomarkers, we found that 6 biomarker proxies are sensitive in serum basin to the carbonate organophosphate change. As we can see here, this biomarker successfully divided serum oils into 2 subfamilies. Now, what is the implication to the petroleum system models? Now, we divide the family into the family A and the family B. The family A is possibly derived from deeper carbonate source rock, the deeper marine. It is supported by the relatively low C26 per C25 tricyclic terpene with dominant diatom and radiolaria input, suggested by the relatively high C29 per C27 styrene ratio and C28 styrene percentage. This environment, because it is deeper marine, then it is low oxygenatic, so it will give a good preservation for bacterial input. Therefore, the family A have a relatively high Hopane per styrene ratio. Family A is mostly accumulated in the shallow fuva formation, but also appear on the ocell and near field. While the family B is possibly derived from shallower marine carbonate, suggested by the relatively high C24 per C23 tricyclic terpene ratio, with dominant algae and plankton contribution suggested by the relatively high C27 styrene ratio. Because it is relatively shallower, then the preservation is less good, then the Hopane per styrene ratio is relatively lower than family A. Family B is accumulated in the deep Manusella formation reservoir in here, the blue one in the southern part, and possibly expelled from the Manusella formation from the shallow carbonate. So what is the petroleum system history? First, Saman-Saman formation that represent deeper marine carbonate expelled the family A crude oils into Manusella carbonate. Then, because of the thrusting, the Manusella formation that are relatively more north become mature and expelled the family B oil into the Manusella formation here. The previously accumulated family A will be leaked because of the thrusting and migrated into the shallower fuva reservoir, but still there are some samples left in the Manusella formation. So to summarize, the genetic and origin of serum crude oil is not simple as previous studies point out as single carbonate source oils. We found that these carbonate source oils still could be further divided into 2 subfamilies, which significantly renew and improve the previous 1980s concept that has been widely accepted for serum basin. Moreover, the concept established by this study may also be applicable for other carbonate-dominated petroleum system in which the carbonate-derived oil still could be originated from several organophages that will open up more potential exploration play, and it will be very useful for exploration, especially in Eastern Indonesia. Now, this is several challenges that must to be done to support our proposed model based on oil geochemistry study, such as adequate oil to source rock correlation, because this model are developed from based on crude oil geochemistry, and then basin modeling to confirm the timing of expulsion. Actually, both of these stuffs are part of my thesis, and I'm still working on it. And then analyze the degree of the post-expulsion hydrocarbon alteration, because to confirm the timing, we must do this also could be observed by the different degree of hydrocarbon alteration. And this already explained in my previous talk. I believe it is the YouTube video still could be accessed, so you could find it there, my presentation. And applying our concept, testing our concept to other carbonate-dominated petroleum systems, such as in the Sulawesi or in Bintuni or in Timor. That's all my presentations. I would like to acknowledge CITIC Seram Energy Limited and Pusat Survey Geology that have provided the data and allowed this research to be presented at International Seminar on Earth Sciences and Technology 2021. Please, you can see my other talks, maybe in the YouTube, entitled The Significant Meaning of Biodegradation to the Petroleum System of the Seram Basin, Eastern Indonesia, Evaluation on the Basis of Physiochemical Composition Variation of Seram Oils. Thank you very much for your attention. Please feel free to ask some questions and discussion. Terima kasih banyak.
Okay, well, thank you very much, Mas Bari, for the presentation and to introduce us to the new concepts of this serum oil. Okay, well, I would like to invite all participants to pose questions or maybe raise hands if you have some questions to Mas Bari, please. We'll check first in the chat. Okay, Pak Ray, please you may open your microphone and pose your question.
Okay, thank you, Barry. Again, as promised, I follow your second presentation. Very, very insightful. Yeah. So, in terms of basin modeling, again, how long it is between the maturity of the source rock prior to the thrusting, because the thrusting is very young, right? It's in tectonic. It's very it's still active today. So probably could you explain like what time range in between those two events?
Okay, thank you very much for the question, Pak Rinaldi. It is actually a very good question. And it is still a problem until now in my thesis, actually. But currently, I've already solved that problem, so I could explain it. Please, I want to share with this slide. So based on my palinspatic reconstruction, the thrusting is started from the southern part. So the implication of the thrusting and based on our modeling, the thrusting gives significant effect to the source rock maturation. So because of the thrust, it adds the overburden, then the source rock become mature. So based on our study, in the southern part, the thrusted section in the Saman-Saman formation, it is mature. The Saman-Saman formation is mature due to the thrusting. Then it expelled oil to the Manusellar carbonate. Then in the relatively younger, based on our modeling, in 1 million years later, 1 million years annum, we can see that Manusellar formation become thrusted. So the thrusting become to the more northern part, maturing the Manusellar formation, but also destroying the silt of the previous accumulated reservoir. So yeah, the family A expelled, and the family B is migrated to the intraformational, to the good porosity intervals.
Okay. Maybe I just it would be helpful if you post like where's the isomaturity line here in this section, like because in this section it looks like the Saman-Saman and Manusellar formation is buried at the same depth because of the thrusting. So are they maturing the same time, or like you said, Saman-Saman mature first and then Manusellar mature?
Yeah, thank you very much, Pak Rinaldi. I do agree with your recommendation, and yeah, that's the challenge for the Seram Basin actually, because there is still a debate between Saman-Saman and Manusellar, because Saman-Saman and Manusellar is equivalent. It is only a different phases. Saman-Saman represent deep marine and Manusellar represent shallow marine, but there are also some literatures that say that Saman-Saman is relatively older than Manusellar. But your recommendations will be very helpful for my thesis also. Thank you, Pak Ray.
Okay, thank you so much, Barry.
Okay, well, thank you very much, Pak Ray, for the discussion, and thank you once again to Mas Barry. Because of the time, I think we will continue to our next oral speaker. So I would like to invite Bu Tasnim Lubis. So she's a lecturer in Universitas Sumatera Utara, and she will give a talk entitled Balancing Nature and Landscape Conservation Practices of Lukon Community in Simele Island. I'm sorry if I mispronounced something. Okay, so Bu Tasnim, you have 15 minutes for your presentations, and we will have 5 minutes discussion afterwards. So please, Bu Tasnim, time and place are yours.
Yes, thank you very much, Ibu Maria. And also, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The invited speakers and also the oral presenters. Please allow me to share my screen. Yes, can you see my PPT?
Yes, Bu.
Yes, great. Well, I'll try to maximize it. Yes. So this is our paper entitled Balancing Nature and Landscape Conservation Practices of Lukon Community in Simelu Island.
Excuse me, Bu Tasnim.
Yes, can you hear me well?
Yeah, please, could you please turn the slide in presentation mode?
Pardon?
We couldn't see your slide now.
Oh, really? Okay, I'm trying to stop share again and trying again.
Okay. Okay, now it's fine. Maybe just please put on the presentation mode. I mean the full screen mode.
Yeah, maybe I can put it. Okay, that's okay.
Okay, thank you.
Yes, so this is our paper entitled Balancing Nature and Landscape Conservation Practices of Lukon Community in Simelu Island. So in this study, I collaborate with Ahdial Fahan Abus, Ramlan, Ibu Tuti Aryani Nasution, Nurul Adila Alatas Abus. Okay, so this is the background of the study. The issues about the balancing and landscape conservation practices, about working at different scales is one of the greatest challenges of large landscape conservation, management of landscape at increasingly larger scales is proving critical as understanding of large scales stresses such as climate change increases. And also landscape conservation is an approach that brings peoples together across geographies, sectors, and cultures to collaborate on counseling important landscape and the myriad ecological, cultural, and economic benefits they provide. So from our preliminary observation in Lukon community, what is the unit of Lukon community landscape conservation management toward balancing nature? Simelu Island is an island which is located on the westernmost of Aceh province. It is the small island, which is a really maybe you have heard about the epicentrum tsunami on 2004. It is really close with this island. So yes, I can say it. I zoom it. Okay, maybe you can see it on the right side. This is the Simelu Island, and the Kon community lives in the Alafan district in this island, and they are a minority in number. So from 89,327 citizens in the Simelu Island, there are also only 650 speakers. Well, so this is the topography of Simelu Island, which is consists of hills. So this is really help them in order, in case if there is something happens such as tsunami, so they have to run to the higher places to save themselves. And yes, Lukon lives in Lapaha and Langi village, which is located on the western on the Simelu Island, and it is really difficult to reach actually because yes, right now it is after tsunami 2004. There is a lot of aids from local governments and also from abroad. So there is a good road, but still, sometimes if the huge storm or maybe hard wind, there are a lot of trees falling down to the streets, so it is not easy to come. Well, what I'm talking about here, more to what I'm trying to focus in this paper is talking about how they manage the rice field landscape and also how they manage their working of how to manage their life because most of them are farmer and also fish catcher. So, for example, this is the landscape, the natural landscape practices in their rice field. You can see that from this picture. It is this is actually based on this data topography, it is not really good to grow well the rice field, but they have to grow it because it's a standard for the main food right now. So, so this is the rice field, which is they have to manage and only grow it for their having, but it is not for commercial or they have to sell it. The objective of this study is to describe the Lekon community daily interaction with the natural environment to preserve nature's balance and landscape conservation in social spaces conducive to sustainable growth. Well, as we know that conservation, it is clear that conservation of biodiversity is not only possible through protected areas, as many species and habitats are beyond their borders. A good network of interconnected protected areas and an appropriate management method should ensure to the survival and existence of many species and provision of ecosystem services at the regional level. Connectivity and putting a stop to habitat loss and fragmentation are part of a number of conservation strategies at the national and regional levels. So about balancing nature, the balance of nature doesn't exist and perhaps never has existed. The number of wild animals and constantly varying to a greater or lesser extent, and the variation are usually irregular in period and always irregular in amplitude. Each variation in the numbers of one species causes direct and indirect repercussions on the numbers of the others, and since many of the latter are themselves independently varying in numbers, the resultant confusion is remarkable. So the precise balance of the benefit delivered by restoration, be that at the individual site of at a number of locations, and the communities that benefit from these services will be determined by the decision and action taken. So we need to carefully consider who will benefit, who may be affected, and how. Therefore, we need to think holistically about our action when restoring individual integrated ecosystem or developing a strategy across a broader jurisdiction, understanding and the benefit that healthy ecosystem can deliver and the trade-off implied by different choices. So the method we use in this study is take a qualitative strategy and investigate procedure to comprehend social or human problem based on a holistic description, ethnographic technique or ethnographic method which is applied in this study. It is proposed by Spradley on 1979, which is consists of 12 stages. So by using these stages, we try to analyze and also collect the data about the balancing nature and also how they manage the landscape. In one of the stage in domain analysis, we have to determine what is the relationship between Lekon community effort and then how they balance nature and landscape conservation. So they do that because they have a reason. So they're really aware and that they live in the remote area which is have a huge disaster, especially from the ocean because the islands surrounding by Indian Ocean. So for the result of the study is indicate that Lekon community practice environmental stewardship by avoiding mechanization and chemical use in growing rice and rice fields. So they didn't use this chemical and they did not use fertilizer. Even the government give to them, they don't use it because they don't want to trying actually to make the balancing the harmony with the environment. And also they use kerbau, it's really the animal lives there, to pluck and use traditional way to spread the seed and still use wind to separate the rice grain from the stems and using wood zinc, like I showed you previously. They have to cover their rice field with the zinc because one of the dangerous animal is a white boar. So this white boar will damage their rice field. So that's why they have to spend money to buy the zinc and also wood on. They can get it from their environment, but they have to buy zinc in order to protect their rice field from this animal. And the fish catcher use traditional tool to catch the fish, like bubu. It's made of bamboo and rattan, and also temba. By using temba, they have to give to the sea, and then they can use it. It's made of wood and rubber, and also traditional fishing equipment such as a fish pole. So, as a conclusion, the delicate balance in nature and environmental preservation is preserved. Avoiding soil and water damage promotes landscape conservation, resulting in a more natural and beautiful landscape. This is because the Lekon community manage the area sustainability by utilizing natural resources in accordance with local wisdom values and belief systems. So they know about how to manage their rice field, about how to catch the fish. It's from their folklore. And so one of that, for example, is Inapi-napi means the story, or Nandong. They really obey what the ancestors said because they know that they don't live in a, comfort area. Actually, they have to alert and they have to be aware if something happened and how they get the information. So they really get the information from the local wisdom, and it's transmitted by their ancestors. I think that's all that I can present. This is Lekon language. Tarimo kasih now means that thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Bu Tasnim, for the presentation. I find it very interesting because landscape conservation is nowadays one of the hot topics concerning ecosystem and for our next challenges also to the world.
Hello,
Okay, maybe now I would like to invite all participants. If you have some questions, please post it in the chat features, or maybe you may also raise your hands and post it directly to Bu Tasnim. And while waiting, Bu Tasnim, actually I was curious, this Lekon community, actually what are they? Are they a tribe or sort of a people who speak similar language or something like this?
Yes, you can call it tribe because Lekon is belong to their language actually. So they only live in 2 villages in one district in Simalu Island, and their number is only 650. Actually, the language is endangered right now. So it is very important. So that's what I do actually, documented the language, and it is included all of their knowledge because language consists of knowledge also and experience. So this is what I do, and also my teams they really help me, and also Mr. Adiel Farhan Habus is also here. Is a architect, landscape architect. Help me in how to manage this information and also make a relationship with the landscape management in the Lekon community.
Right, very interesting. Yeah, maybe one more, if I may, would ask me. So, concerning landscape conservation itself. So, what do you think this conservation should lead to? Should we conserve the landscape and ecosystem back to their initial condition, or shall we design a new kind of conservation to really adapt our like future challenges like the climate, or I mean you mentioned also a problem in economics benefit and something like this. What do you think, Bu Tasnim?
Yes, it is very unique about this community. Well, I can call them a tribe, and it's like a negative sense, so community, because they still obey and also still, how to say it? I mean, they really obey what the parents or the ancestors say because they really know how to do it. And until now, when the first time I was there, last 2 years, you know, one word, the first word popped into my mind is, the place is very original, and then I wonder how they live like that. I mean, we are living in a globalization. We live in this situation like technology and something like that. But when I try to study about the language actually, and then try to document it, them. Yes, they really obey because they know how they live there. They don't greedy, I can say that one, explore or something, because yes, if we see that their place is very promise to make it as a ecotourism, for example, but they know what will happen. I mean, like, what affect their life, because it's not. They still believe that they have to keep the balancing. They have to maintain the geography, like for example, the marine and also the land, for example, because they don't want to damage it, and they don't want to how to say this one. They really obey, because for example, I just can give it like this. For example, they use word smong. Smong means that tsunami, means that they always tell the story about that. And when the huge comes, when the earthquake comes, and then the low tide, and then they don't do anything else, just trying to save their worthy document or something. Like, no, they didn't do that. They just running to the higher place in order to save themselves, and they really know that means that they really obey about what they parent or ancestors said. So what they parent or ancestors do for fishing, about how to manage the landscape, like a rice field, because mostly they only live as a farmer and fish catcher. So this is what they do, and they still do that. And by the deep interview, I really understand that they try to maintain that, because they try to be safe and to survive, because they know if something happens, there is no quick help or aid from others, because they have it. It happens at the time, so they know how to do that, and they always like an alarm, because listen to their folklore, listen to their ancestors' story, something like that is really become their local wisdom, and they obey about them. So there is no greedy. That one, they just live for their life to survive. So I think this is because they also a small, we can say, because a small in number, something like that. So they try to survive. Maybe it answers your question, I hope.
Yes, thank you very much, Bu Tasnim. Yeah, it's a very interesting research, and I hope you can carry on and bring us back some more results in the next webinar.
Thank you.
Yes, thank you very much, Bu Tasnim. Maybe due to the time limitation, so we will move to our next oral speakers. So Ibu Jenian Marin. She's also a lecturer in Geological Engineering Department, University of Diponegoro, so Universitas Diponegoro, and she will give a talk entitled Characteristics of Volcanic Rocks and Associated Intrusions based on Petrography Analysis in Jari Krondonan Area, Bojonegoro Regency, East Java. This talk will be delivered in a video, and we will have afterwards 5 minutes for the discussions as always. So please, Mbak Indah, you may start the video. Thank you.
Hello, ladies and gentlemen. I would like to thank volcanic rocks and associated intrusions based on petrography analysis in Jari Krondonan Area, Bojonegoro Regency, East Java. I would like to give you an overview about my study. This is the introduction part. Geologically, my study area is a volcanic complex named Pandan, located in Bojonegoro. The Pandan volcano consists of several volcanic centers and intrusive rocks. Based on the previous study, the Pandan volcano is part of Sundarbanda Arc, which is a quaternary volcanic belt in Java. Based on other previous study, this volcano is currently inactive with the characteristic of andesitic, but we can also found some geothermal activity in the form of hot springs in the vicinity of the area, especially in the north part. And the objectives of this study is to identify the distribution of volcanic rocks and intrusion of the research area, and to determine their petrographic and mineralogical characteristics, to interpret the magmatic process and petrogenetic aspects. This is the map of the research area location, in the Bojonegoro Regency. We can see in the small box in the southern part. As for regional geology, we can see from this map, this is the part of regional geology map from Pringgo Prawiro and Sukido, 1992, and we can see Pandan volcano in this area and the research area located in the northern foot slope of Pandan volcano. And the volcanic rock of Pandan volcano is situated atop Paleogene terrestrial marine clastic and carbonate rocks from Pucangan, Sonde, Klitik, Kerek, and Kalibeng formation. The research that I use in this research, the first one, we use a field mapping and observation of geomorphological and geological aspect. The area is about 10 kilometer square, and then we do the sampling of intrusive and volcanic rocks to prepare thin section. There are 8 samples that we've been prepared for thin section, so we can determine the mineral composition and textural characteristic by petrography analysis. The results of this study will be given in the next slide. For the geological features, we found 2 sites of andesite intrusion in Gunung Lawang and Gunung Jati in the northern part of the research area and the southern part, and then 2 sites of andesitic lava, Gunung Puru and Gunung Watu. You can see in the geological map here. And for geomorphological feature, there are steep conical hills and volcanic slopes situated in the northern foot slope of Pandan volcano. For the rock structures, we found columnar joint and sheeted joint, and also the outcrop is shown as a xenolithic structure in the field. And for the megascopic identification of the rock, all of the samples are andesites with some variation in mineralogy, but all of the samples in the outcrop have porphyritic texture, and the visible phenocrysts are plagioclase, pyroxene, and hornblende. We found a volcanic breccia as the lithology surrounding the other volcanic and intrusion. There is a documentation in the field. You can see the geological features in the left part of this slide is the geomorphological and structural aspect. In the Gunung Lawang, we found columnar joint, and the Gunung Jati, the both two sites is an intrusion. This morphology is evident by the steep slope and conical hill, and then Gunung Watu and Gunung Puru is more gentle in the slope, so it is not as conical as Gunung Lawang and Gunung Jati. And then in the right part of the slide, we can see the picture of the xenolith found in the outcrop. The xenoliths identified as gabbro and then metamorphic, something like phyllite, and we can also determine the texture, porphyritic texture of the sample. The summary of petrography analysis can be shown in these 2 tables. Table 1 is mineralogical composition of rocks based on the petrography analysis, and the table 2 is textural characteristic based on the petrography. From the mineralogical composition, we can divide the andesite into 2 different rock types. The first one is hornblende andesite, as found in Gunung Lawang and Gunung Watu. So the main phenocryst is plagioclase for more than 50% of the phenocryst, followed by the hornblende with the percentage about 20 to 40%. And then the pyroxene andesite found in Gunung Jati and Gunung Puru also have plagioclase as dominant phenocryst, and then the second dominant phenocryst is clinopyroxene and autopyroxene. All of the rocks are surrounded by the ground mass of volcanic glass, and there is some accessories mineral like olivine, and then sanidine and quartz. For the texture characteristic, this is in the column you can see the texture from porphyritic and glomerulitic zoning, pilotaxitic, poikilotic, and sieve, which is in some sample is frequently found and in the other sample is rare. For the example, in the pilotaxitic and poikilotic and sieve is more frequent in the Gunung Puru sample. This is the photomicrograph of gene section samples from figure 7 to figure 10 of different location. We can see in the picture there is some special texture such as zone plagioclase we can found in Gunung Lawang and Gunung Jati, and then sieve plagioclase in Gunung Watu and Gunung Puru. Also in Gunung Puru we can found a pilotaxitic ground mass, that the ground mass have some flow orientation, like as seen in yellow arrow mark. And also we can also find glomerocryst in the Gunung Watu. Based on the result, we can discuss some findings here. The first one, the volcanic rocks and intrusive rocks are andesitic, composed by plagioclase and hornblende and pyroxene. This is similar to the result of Yudiantoro and Takashima in 2018 from Pandan volcano itself. And then the xenoliths show basement interaction during magma rising, like suggested by Smith et al. 2005, that the basement of Kendeng Rembang zone could be from a phyolite series. That's why we found gabbro and metamorphic as xenoliths. And the porphyritic texture indicates the crystallization phase of andesite as manifest by phenocryst and ground mass. The glomerocryst from the glomerulitic textures shows a symbiosis or crystal accumulation during magmatic fractionation. And because the glomerocryst consists of plagioclase and pyroxene in the same size, we can also infer that the two minerals have heterogeneous nucleation, and magma mixing changed its composition as suggested by crystal zoning and sieve texture, and the latter is evident from Gunung Puru samples, which extruded as lava. For the conclusion, the volcanic activity in Pandan volcano from volcanic rocks and intrusions extends to the northern part to the foot slope, and the rock type in the research area is porphyritic andesites with fine-grained ground mass and main phenocryst of plagioclase, hornblende, and pyroxene. The rock texture indicates magmatic processes such as fractionation, basement interaction, magma mixing, and change in magmatic composition. For the ongoing or future research, we plan to do geochemistry analysis to determine magmatic affinity and to construct petrogenetic model. This is the reference we've been used in this research. Thank you for your attention.
Thank you very much, Bu Jenny, for the presentations. And I would like once again to invite all the participants. If you have some questions, please raise hand, or you may also use the chat features to post your questions. Bu Jenny, maybe while waiting, are there some special petrographic or geological features of the volcanic rocks in this area compared to the surrounding area in East Java?
Good afternoon, Bu Maria.
Yeah, good afternoon, Bu Jenny.
I couldn't catch the compared to which location?
To other surrounding area in East Java, are there some special features of these volcanic rocks in this study area, Bu Jenny?
All right. So the main volcanic complex is Pandan volcano, located in the southern part of the research area. Based on the petrographical study, the difference is only in the mineralogy, which is the accessory minerals. In our research area, we found clinopyroxene and orthopyroxene and hornblende. Based on the study by Yudianto and Takashima, they found the main accessory minerals is hornblende. So this is maybe a variation from the basaltic andesite petrology.
Okay. There was also a mixture of magma, or something like this concerning the petrographic results.
Yeah, based on the texture, for it is evident from sieve texture, but sieve texture can also an indicator for decompression while the magma is rising from the magma chamber to the surface. And for the magma mixing, we can also find the evidence from the zone plagioclase. So the zone plagioclase means that there is a difference in composition between the inner core and the outer core of the plagioclase. Like that.
Right. Okay, very interesting results, Bu Jenny.
Maria.
Yeah. Okay. Are there some other questions from the participants?
Yeah, please.
Or they are all because it is the last session, maybe a little bit sleepy or something. Okay, we still have 1 minute. If there are some questions. Okay, well, I think the time is up, Bu Jenny. Sorry for the time limitation, but thank you very much for wrapping up this oral session very nicely. And I would like to thank once again all invited speakers, Professor Edi, Pak Eka, Bu Gebi, as well as our wonderful speakers, Mas Bari, Bu Tasnim, Bu Jenny, for the insightful talks. And also, I would like to thank all the participants in this virtual room. So we hope that you are all getting a lot of new, important, and useful informations and insight from this session. And tomorrow we will still held this seminar at the same time. So you may have a look in our program in the abstract book or other source of informations. Maybe you can find it also in the main room or in our website, isesst.fitb.itb.ac.id. So I officially close this session, and I hope to see you again tomorrow. Stay healthy, and thank you very much, everyone.
Maria, see you tomorrow.
See you tomorrow. Thank you, Pak Edi.
Thank you. See you tomorrow.
Thank you.
Thank you, Mas Ray. That's very good, Mas Ray.